Hello guys, we are live I suppose. A new day, new start, more lead code, and we will do it eventually. Um, Alright, let me take this out of sight. Alright, we have music, we have audio. I guess we are good to start. Alright. Um Hey, I have a question. I have tight timeline. I think I'm wasting time studying useless stuff. All right. Go on, go on. Um, how do I know what to study and how much study? That's a brilliant question, guys. I mean, oh, lazy lobster. You are definitely right. Like there is no 100% correct or false. I'm thinking going into cloud on that. Also, and also, like, can you specify your quest a little bit more? Because, for example, I dedicate most of my time studying lead code, but at the same time, I should also keep building projects, and also I should learn like a Python, C++, because I apply for different jobs. But for example, yesterday I only spent studying lead code. A day before, I only spent the building projects. So dedicating your time, like a time management, quite important, and I cannot say I'm quite good at it. But about cloud and DevOps, it depends on the job you find. For example, I started learning C++ because I've seen a job opening basically. So in robotics, and in the job requirement they say C++ knowledge required. So that's why I started. So it depends on the job actually. Like, I mean, it depends on your goal basically. So what you need. For example, the another reason why I study lead code, like, because I've seen lead code questions asked during the interviews. Like, they come up, and like I failed a few of them, so I decided I should learn this properly, and then I will continue applying for jobs excessively. But first I need to learn this because there are international companies, and like almost every company that I know ask this. There are other companies as well where they give you take home project basically, and you build it, and um, you get it basically. But right now, I'm not sure I'm open to any roles, but I have 3 months of timeline. So you have 3 months timeline, and you want to, uh, but which topics in are in your topic, in your list basically? Cloud, DevOps. I cannot say, yeah. I mean, you go cloud or DevOps, or you know Java, Python. What you like we can maybe you can start with what you like, what you enjoy, what you are good at it. um and depend I mean, it depends on job you aim basically. Cloud and DevOps you want, but that area is not my specialty actually. Like, I don't have experience in those areas. I have worked as a CRM consultant, and I have experience in automation and some Java basically. I'm okay on problem solving, but I never gone deep in any topics. Yes, that's the problem with juniors basically. I am kind of junior as well, like a junior mid-level, whatever. But that going deep most probably will come to us when we start a job, and let's say after 3 years, 4 years, and then we will feel that we know like a deep knowledge basically. I believe this feeling will come through the experience, because there are tons of topics that we can study, all right, but like, it is not possible. I mean, this is my perspective. I don't see it's possible for us to go very deep, like, without a real experience. Because how can you make sure that, like, this is deep? All right, where is the limit? So, experience, like a real job experience, uh, should be answer to your question, lobster. This is my answer. Because real job experience is something else, and you Like there are some information you can find online on YouTube, but there are also some others that it's only come through with real job experience. What do you think I should do if I skip interest and just wanna get a job? This is also doable. This is also doable. Like if given the current situation with the economy, um, like actually the reason why I started streaming is also because of I want to have a online existence, online name for myself actually, because this is the best time for for doing it. Because like it is not enough for us to know one programming language or one thing. Like we should be proficient on various things. Like lead code is one of them. So like a streaming, like a meeting new people, building an online entity is something. Like a trying to be um, a good communicator is another field. Like I also for example learn to learn speaking German. Like broadening your expertise, broadening your skill set. Like this is what this is what we should do, I suppose. And like that's why I learned Python, C++. And also like I built productivity apps for me, and also like I publish them on GitHub so that you can use it as well, to make the learning process efficient. So like we should do different things at the same time. Like in this era, um we should do this. And like you can start, you can work in a job, and you can still build new skills, even though it is hard, because after you come home you will feel very tired. But we should build these skills. For example, you can rest and maybe like a 1 hour 2 hour, and then for the until you sleep, maybe you can learn a new skill basically. It is hard, but the beginning phase, like beginning part, is harder, I believe. And after seeing your road, all right, then it will be easier. This is my opinion on this. And yeah, you can do it too. Um like I've been spending some time, all right, studying lead code, maybe even more than necessary. Like I'm not still good at it. Like I can maybe pass, maybe fail during interviews, but I want to get to a certain level where even though I fail, I will say I've done my best. So this is like currently I'm not in a position where I can say this. I want to say like I've done my best. So um but luckily my family supports me. So um like it depends on the situation you are in as well. All right. Because if they didn't support me, I wouldn't be doing this. I would continue in my CRM consultant job. That would be different career basically. Now I'm switching my focus and trying to find maybe like a more well suited job actually. It is not easy. It is not easy. It really depends on your situation. Like I don't know you very well, basically, like from your questions, from your text, but it depends on the situation. So I cannot generalize it, but let me tell you that it is not easy. But you can do it too. Um, but the thing I know is we need to broaden our skill set, like a being good communicator, like a knowing algorithm stuff, and sharing, teaching. I know that while we teach, while you teach, you learn better. So this is another reason why I stream actually. Um, so like I can say this, like I cannot say like do that, do this, but I can share my experience, my opinions. Um, yeah, like for example, I need to complete this need code 150, and it takes good amount of cognitive energy. Alright? And it is not easy, but luckily we have, like I have you guys yesterday. Lazy Skimmer and Solaris and Americano helped me participate the contest on Code Forces. Like they helped me a lot, and I will continue participating those um contests basically. Let's see. We will see, man. We will see. Like, it is not easy. So like maybe like maybe 20 years ago, 30 years ago, like in each time, I mean every time there are some, easy X aspects and hard aspects. But currently knowledge gets, you know, easier and easier to get basically. So we should decide what to study, as you said, very carefully. And like, it is hard. It is quite hard, lobster. Like for me, these algorithms will bring me like a not single, advantage, multiple advantage. I am making my brain, functioning better, understanding algorithm better, so I can use this in various areas. All right. So this is one. The other thing is like these questions are coming up on in interviews basically. So this is another thing. And the third thing is when I want to build something amazing, right? Like a maybe game, but with different, you know, character abilities, for example, right? Even though AI can build code very well and making unique, adding something unique features, it is still cannot. I mean, it cannot add it. So, but if you know those algorithms, if describe what you want very carefully to AI, then it can start building, or it can start doing what you are um, telling it to do, basically. So this is like I am getting three different advantages by studying this. Um, so yeah, like if you have multiple reasons to do something, then um, it can be easier to follow that path. But I cannot say you should follow that, because nobody knows, man. Like things are changing very quickly. So even the 6 months earlier truths and facts not cannot apply to today's reality. um yeah. So for example, another thing, I want to start reading books more and in an organized way. Maybe like a 30 books a year. So like I am postponing it. All right, because like I see the delete code, like yesterday I spent all of my time studying this. Like time management, like we should do better, definitely. Like I don't know if I answer your question, but these are my opinions, Lobster. These are my opinions. um and we will start with these, and I will create some review notes, guys. um all right, let's let's do this. Let's add echo, like this invert mm, problem. And here, like I mean, at first we change left with right, and then we are doing this um operation for all the things in our left subtree and all the things we have in our right subtree. um yeah, maybe I can draw this line and this line. The main function, and func for which subtrees. All right, we can, I guess we can save it. Let's go to next mark. Climbing stairs, a DP question, defining your problem using subproblems. And even better, we use like a two of our subproblems. All right. Um, let's make it full screen. Let's see. Actually, Hmm. This is a bottom up. I wanna see top down first. Um, so let's open another tab, and there I will want to see its top down solution, right? Uh, Climbing stairs, top down in Java and Python. And come on, guys, we also study C++. and give me their unoptimized recursive version and then optimize, right? And the optimized recursion version will be our top down basically. So I want to see both of them because I solve DP problems, starting with unoptimized solution because it is easy. It is easiest to come up with. Let's see. And also, let me start our, I don't know. This is our room, guys. If you want to join, room, you can join us here. All right. We have our answers. Let's see. This is Java. And actually, I don't want to see the name, but I want to see them with um, basically func. All right. Um, can you make the function names func? Because like I really love to see my recursive functions as funcs, all right. So that in every, I mean, it is not dependent on the question. I see the same function so that it's easier to memorize basically. Sentinel value. All right. Um. So, and actually, I don't like to see the functions, recursive functions being called like in the return statement because I want to see explicitly so that it is even easier. Right? And also, like in return statement, don't add our func recursive calls in the return statement, but make it explicitly. So create, for example, integer x and integer y, assign their the return values to them, and return summation of them. For example, for the climbing stairs, and do them. I mean, do this in other. No, do this in other languages as well. Like explicit is the way I learn. The reviewing part is quite important, guys. These are the questions that I have solved earlier, even before I start streaming. So let me update our pinned review. Bring our study notes on lead code. Let me pin it. All right. Do we have them, or is it still creating them? Inspectable. Inspectable, yes. This is the word we need. Inspectable. Um yes. I really love this term. Inspectable. Because most of the time coders tend to make the code efficient, but it becomes harder and harder to understand, to see what function it does. So making them inspectable. Yes, we have them actually. Let's see. Yes, for example, we call for, like this is our one sub problem, right? One of our sub problem. Let's go back here, paste it, and also even better. Um, Actually, we know the climbing stairs problem, but let's open climbing stairs. Um, it says easy, but this is not easy, guys. Let me tell you that. Let me tell you that. So, and it is a question image. All right. So this is you know, an optimized way, like a top down. We have like this is our first sub problem, right? First subproblem, the second subproblem. So we manage to define our current problem, right? Current problem using subproblems. This is crazy, guys. Like basically, you don't need to do anything. Basically, you need to solve subproblems again and again, right? But each subproblem brings you more subproblems, and when like there is also an end basically to that, and that end is here. So you basically uh, depend on the answer from your sub problems again and again. Sub problems they are depending on their sub problems again. But at some point, this is where you start building your real answer basically, and they basically accumulate, right? Accumulate, unwinding and accumulating, and bringing you a basically real number, right? um Top down memoized. So let's also have it. um Actually, uh what can we add? Actually, yeah, like this part, and we can say, as you know, these are your sub problems. How would you describe your sub problems that will bring you joy? All right, let's add these colors. Ah, nice. All right, while adding, there is a shadow. There is a shadow. Let's press save. Nice. And for top down, I mean, yes, top down. And the thing we memorized is like above basically calling our function. We basically say that if you have the answer, like before reaching um to return value from our recursive function, we first check. I mean, we need to first check if there is, if there is answer for that subproblem. No, not that subproblem, but the problem itself. Nice, guys. Nice. Very, very nice. So, I really want to make this part blurry, right? And also this part blurry. So, and as a hint, um, do you expect a value from your subproblem, or press enter? Um, these are our subproblem, and Yeah, like we know, and also we should also take this, make this blurry, right? And then this. So for hint, I mean hint for this would be, what do you fill up? All right, save it. All right, so we basically check like inside the current stack frame if we have an answer for the current problem. Like, because I remember I basically confused if we were checking the sub problems like answer, like for example n minus 1 and n minus 2 sub problems. But no, we have a memorization array, and like for the current problem, all right, about like before calling out, I mean before calling our sub problems, calling for sub problems, we check we check if we have already an answer for the problem itself, but we are doing it inside the stack frame, all right? I mean, we like this function is called basically, right? And when we are inside of this function stack frame, we check if we have it already. And after calling our sub problems, the answer, for example, I don't like this, like this should be x plus y, like this is how my brain works basically, right? But I don't need to drive the meaning of memo, but it is not too complicated. We literally see it over here. All right, let's press esc escape, and let's see its Python solution. All right, this is not too complicated. um Maybe I can blur the Python part instead of the algorithm. It's instead of algorithm part, right? um so for example, self. Yes, first one is self. Are you selfless person? And integer, this is the parameter for our problem, and this is how the way we the parameter basically, right? Declare a parameter inside a method's arguments. All right, I suppose in Rust this is the way, right? Like in Java, you first show the type, indicate the type, and on Python we don't do that. Hey yo, Dumpy Dun, welcome man, welcome in. Nice, good. Thank you, man. Thank you. Like we will, I'm reviewing the questions that I have studied earlier. Um, yeah, like nice, man. Like thank you, man. Um, and we have, actually this is a function, but how about, I suppose this is not a class, like method inside of method. This is interesting. This is interesting. This problem seems hard in starting when you, yes, exactly. Even on lead code it says easy, but it is not easy. All right. As you say, if you know, like if you don't know the fundamentals, the recursive idea, it's not easy. It's medium. Yeah. Like maybe this one as well. Why do we have two functions nested? Let's save it. And this is memoized version. Let's take a screenshot. Is there a command to see fish cam, or you decided? Actually, yes. If you run follow me, it follows your last added fish, basically. Can you run follow me command? Um, I think I also. Which screen was that? 7, right? Yeah. But actually, um, I will add an overlay so that even we are in this scene, you will see the game actually. We have this for hunt, but let me add it for follow me as well. Um, Not this one. Yeah, 5. All right, 5. Let me also follow me. Yeah. All right, 5 is for showing. All right, 5 and 1. We have our boards in our ocean. All right, you can add a task, and if I will run follow me, it will show my fish to everyone, 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 to everyone. Yeah, like making it for you only would cost us some, um, CPU usage basically. But I have the game running right now, and you when you run a command, it triggers the game and it triggers camera movement. Yeah, that's not. Yeah, yeah. But I will add this overlay thing, so that when you run your command, instead of needing, switch to this scene, you will see an overlay basically. Actually, we have this. All right. We have this for hunt, but let me add for follow me as well after doing these. Um, so for memo part, yes, we first check if we have it. This is the way. How do you check an existence of a value in an array in Python? Press enter. All right, we connect this. Um, and C++. Follow me. Let's follow you. You are koi, and you seem like a big fish. All right. Let's see how you're gonna eat your food, I suppose. Come on. Can you run follow me again? Oh, it is in hunt mode, right? Oh, it is in hunt mode? Come on. It can eat. It is either. Yes, it ate. Well done. All right. Also, food. You are getting larger and larger, Dumpy Dog. Nice. Um, while you are feeding your fish, let me handle the C++ code for climbing stairs problem. For unoptimized version, it is all almost same as Java basically, right? Yeah, it's almost same. All right, and for Mimosite version. Yeah. It uses a vector for that top down. All right, guys. All right. So let's add echo, and we have. Hmm, how do you create an array in C++? All right. And all right. Let me blur this part. And we have a sign. Interesting. You wouldn't guess this. Alright. Let me also add this new feature. Mm. And also, like, I would like to have another feature, and this feature is about our OBS. Like before restarting our daemons, um, in main basically, right? Rename. All right. In main scene, when our friends run follow me, we should also show the overlay on bottom left as we show hunt camera movement basically. When they run hunt, we show this overlay basically, right? um so I want this feature for follow me comment as well. So currently I am live on Twitch, so be careful and add this feature for follow me comment as well. I'm writing my journal of last 3 days and I skip while watching your stream. Why? Like we have also task comment, Dumpy Don. You can ask task, and when you run my task, our camera will show your task here. All right. So in our ocean, in our aquarium, we will have your nose basically. And also, like we want this feature for my task comment as well. So when someone writes my task comment, camera will change. And but they should have their priorities. All right. For example, hunting. Um, Actually, like if there are multiple people running like a hunt, follow me, we already have a queue, right? So based on queue, um, actually I guess we don't need to do anything specific, right? But I want to see that overlay for follow me, for my stack, my task and hunt, all right, in the main scene. All right, all right. Now you can run my task and we will see your task in the ocean. It is quite motivating to study. Oh, welcome, thank you for the follow. See possum. Thank you for the follow. You can add your fish in our aquarium. It forced me to follow you just thank you, man, thank you, I appreciate. You can add your fish running by running fish command. Possum, let me call you possum. um you can run fish command to add a fish into our aquarium. I don't care about it. All right, all right, all right. You can add task. You can add a fish. We study lead code. We learn Python, C++. We share our journey. I came because programmer. All right, all right. Welcome, welcome in, man. Welcome in. You will become a fish breeder, so yes, but yes, like we have many kinds in our ocean. Um, uh, all right. This was for climbing stairs. Let's go to the jump game. All right. For jump game, let's first jump game lead code. Let's first paste the image of it. So jump game is a greedy problem, and let's remember the question first. You are given an integer, so we have an integer array, and our goal basically decide if we can reach to the end or not. How are we supposed to do that? Um, so basically, we need a variable, max variable. And yesterday, while we are solving code versus question, there even even maybe it was the first question, right? No, the second question for stack. Um, code versus div 3, right? So like we had this there as well. So we need a variable to hold the maximum location that we can go in each step. All right. So let me um, let me start my note taking application and draw you some stuff. All right. So in each step, we will check how far we can go, and we will hold this inside the variable, guys. Inside of a variable. Come on, you can do it. So let's say we have an array. Like this is easy once you know, but this wasn't easy when I first, was solving it. So we need a variable basic, and let's call that variable um how far. All right. How far is not a good naming, but uh, far. Do you wipe coding? Yes, I do wipe code as well. Uh, Fartest maybe. I don't know if I spelled it. I like AIs, I suppose you said. Yes, I love Cloud Code and Cloud Code mostly. All right, like ChatGPT and the other, they are also good, but I like Terminal and I like Cloud. I will try others soon as well. So in each step, our variable basically, right? We will hold, for example, how far we can go. Like if the how far we can go is like um let's say 0 1 2 3 4, and we like while we are processing um let's say 2 as well, right? So we will say we will update this variable to, for example, 5. And how are we gonna do that? um we will do that by using our max method, of course, right? Max where, and we will assign where um, if the current index plus the value there, the summation of these. All right, this is the idea. What you work on security vibe coding? I play a game that has a player market, and the game has a market API. So Cloud uses the API to get market data for me. Like, is that like a simulation game? Um, all right, this is the question. Do we have the solution? And yes, it is in Python. Uh, hmm, this is jump game, but this is for the other jump game 2 solution. This is jump game 2 solution. This is not jump game solution. Um, let's um, let's put it to here, maybe, right? And now do the same for jump game. Here is docs, developer online doc service overview. What do we have here? Let's see what that is. Is this the game you built, or is this the source that you use APIs? Um, what is this block? Do we have visuals? Develop documentation. Creating third-party tools and applications for Orion. So it also allows you to add new features. Whether you are, why does it look cut off on your stream? Because I use an application and I can see the windows that I open on the side with the REST API docs. All right, ever online. Let's see what that is. It looks like a cool game. I guess it is in space. That's cool. That's cool. Which features are you developing here? And for this, all right, jump game. For jump game for Java solution, we need to make it more visible. Unoptimized recur. Actually, I didn't want it to create. You don't need to give the recursive solution, man. But it is interesting that you came up with the recursive solution. But I want to have like a normal iterative solution basically. I'm not the game developer, I just use API to get some data. I see, I see. But what are you doing with the data? Are you analyzing and, maybe building some models? How do you use your data? Um, do the same as too literal. Yes. So, jump game. Yes. Hmm. I guess there is something I need to remember apart from this. So, let's try to remember that. I don't know. No, man, don't say that. What should I do with my data? I mean, you are just joking. I mean, like maybe you are building some, statistics model to decide to analyze the behavior of the users, the gamers in the game. So stuff like that, maybe predict. Maybe you are making some prediction, right? Maybe which costume will be bought most, like maybe like that, based on the characters that players pick. I thought like that. So the idea is like all of course we have a variable, right? And it holds the maximum reach, max reach actually. Let's call it max reach. Um, but in the code we've seen that there is something like there is a if condition. I just asked Cloud to find my arbitrage shipping opportunities. I have no data analytics going. Data analytics. Yes, yes, data analytics going. All right. I see. I see. I also use cloud. Like for example, uh, I created this app for especially studying lead code. Since I take lots of screenshots using cloud, it works very well, and I really enjoy using it. I can take notes. I can paste images, add audios on top of them, tagging them, coloring them, fetching them, and it is amazing. And now recently I have added a review feature as well. Um, it just works very well for me, um, because no other note taking application could provide this level of space, this level of usage basically, right? I have everything I need. So it's on my GitHub repo as well. So like in ON, we basically hold this value, and as we process each number, we hold the max reach, and when we find a new max reach basically, so yes, if new, basically if new max reach, um we update the max reach. And when we go, after completing this for loop, or even we don't need to wait until, wait for this for loop to finish basically, right? Execute. um Maybe we can have another if, and if max reach is beyond the length of our array, then we can immediately return true, because we don't need to wait. So, and even by the end of it, if we actually, it should be also equal, right? If we length or length minus one, length minus one, it should be length minus one, length minus one, because this is the last index, right? Last index. Our goal is to reach this. As soon as we can reach it, we can return true. But if we didn't return true, then outside this for loop, we should return false. But I suppose we don't have two ifs in the solution, so let's check. Let's check now. Yes, only single for if statement. um let's see what difference we have. We have max reach, and we updated it, right, in each for loop iteration. And candidate, what is candidate? Yes, all right. um so this is how far we can go. We update it, but how about this part? If I goes beyond max reach, we return false. So actually our second if is this max, so we have this, all right. And for this one, actually we return true if we reach it. This is a good approach as well. Let me, I mean let me save it as well. um but here it is doing in a different way. Slightly different, but there's a detail, guys. There's a detail. um the detail is, why do we have, this part to return false basically? Why? Let me check the correctness of my code, for example. Thank you for your cooperation, Surgeon. But the solution I had in mind is like having a for loop and having a max reach variable. And as we see, as we see a new opportunity for updating our max reach, meaning that, summing the I with nums I, basically, right? This is how far we can go. If it is larger than our max reach, we update it basically. So for this if statement, maybe we can use a max method, right? um, like a max reach comma I plus nums I. So this is the way we update, and below it we have another if, and we say that if max reach is greater or equal than length minus 1, length is our inputs array, we return true. This is the thing we have inside our for loop, and outside of this for loop we return basically false. All right, if we couldn't manage to return true, then it means our for loop didn't generate, um, you know basically we cannot reach to the end. So could you please give this solution as well, I mean in Java only? Let's see if it is correct. um, Let me also check YouTube. All right, on YouTube we have zero concurrent viewers, zero chat rate, and zero views, which is very cool. But we will have some friends on from YouTube soon, guys. I know it. I know it. Your shape is good. Early return the moment. Reach return false after loop. But as described, it has one back. Oh my gosh. We should fix it. Nothing stops the loop from processing an index it can't actually reach. Oh, that's very nice. That's very nice. That's the bug. That's the bug. Uh yes. So I asked why we have these, right? Yes, for example, this. So now I get it. So guys, without making mistakes, there is no way we can understand, right? So um, Java. So and also let me add an echo, and yes, gap index. So full part of it, right? This is the part. This is the part where I missed while reviewing reviewing importante. All right. So like I can easily understand the candidate. Like this is how far we can go from that point, and I can easily understand how we update basically. Like as we process each index, we check if we find something greater than our max reach basically. But I forgot this part, which is also which which is quite crucial part in this problem, guys, because like it is quite crucial, right? um the remaining part is kind of easy, man. Looking at it gives me joy. Yes, because like I plus nums I, like it looks very nice. But now let's try understanding why we have something like that. So um we have like these numbers, right? We have, let's say, random numbers, right? And as we process each of them, right? As we process each of them, um this is very logical, guys. Like I imagined, like I thought everything goes smooth, all right? I thought like this example, but we could have, let's say this one, right? Meaning, um like while processing this one, we update our max reach, and now our max reach is let's say 1, right? And now in the next iteration we process this one, right? But like but hear me out, guys. Now for example here, like while processing this, our max reach is 1, well it is, and our new, like a new candidate max reach, let's try calculating it. So our formulation for it is this one, right? I plus nums I is 1, guys, and nums I is 0, meaning it is giving us 1. So our max reach was already 1, right? So we can go, like the farthest we can go is 1 basically, right? And so like we are literally limited, we are restricted, like we got shortened, right? We cannot go. But our for loop, guys, like there's the method we are using, like this for loop, right? So by default it will basically try processing each location, each item, right? It wants to go, it wants to process. So we should stop it, guys. We should stop it. So realize for loop by default will process each item, like each index basically. So how can we stop it? So we need, of course, a basically not a base case, but how can we guard? Yes, this is a guard. We should have a guard saying that if the farthest we can go is smaller or equal, like should we add equalizer, like if it is smaller than our current, most probably yes. If the farthest we can go is smaller than the current, so meaning that, guys, after processing this, like we updated our, like I mean we evaluated, but we didn't update max since it is already 1. But in the next, like after this process, we in the current iteration is ended, and now new iteration begins. And in the new iteration, our I, let me tell you that, guys, let me even use green, right? Our I is 2, right? Our I is 2. Now now actually this is where we can stop our function, right? Our for loop. So this is why we have the less than a sign here, because we don't stop processing here in index 1, right? um yes. So it is quite crucial, guys, because um like we need to behave like a surgical. We literally need to know which index is we where we stop basically, right? um all right, all right, this is good. We made a mistake, we have learned our lesson. All right. And also another thing is it returns false. um hmm all right, so the structure I have used, I mean here, it was depending on, like I mean if we can reach, we return true, and if we didn't return true while processing all the items, then we return false. Like this was my first approach. But here it is kind of vice versa. If we don't return false, we can return true. So basically after processing each item, if we didn't return false, meaning it will mean that we have reached to the end. That's why we return true. But still I don't see, actually, like we can optimize these, guys, because I mean it doesn't check if the max reach is already beyond the our length, beyond our last index. Let's ask this to AI as well. So thank you, Sergeant Cloud. Now I can see why we need to check if we can go or not, right? because max reach could be smaller than the current index, so we should stop. um, so another thing is that in your solution, we basically process each item in our array. But I suppose we don't need to do that, right? Why? Like, because if max reach is already equal or greater than our length minus one, then we can immediately return true. Could you please add that? And do you think adding this case would improve our code or not? Could you please clarify on that? Like, yeah, like its solution process all the items, but there are some cases where we don't need to process each item. Like, if we can reach to the end, then, like, I mean, earlier. Good news. Let's check what it says. That check is already in the version from my last message. The second. Oh, I haven't seen it. All right. Early exit. Yes, the thing I'm trying to describe is early exit basically. Um all right. I guess I have missed it because the thing we have copied here we don't have it basically, right? Um should we remove it? All right. This is good. This is good. Let's add an echo. This is good. All right. Um, should you should or can you process all items in the list, and the first, the second, the first one will be for um early exit basically, for early exit, and it says jump game 2. Are we in jump game 2? Oh, yes, we are. But I pasted jump game. All right, so let's open jump game 2. In jump game 2, basically, it is asking, what was it asking? It was asking how many steps, yes, how, like, minimum number of jumps that we can do to reach to the end, guys. To the reach, I mean, reach to the end. So we need to count basically our steps, but how are we gonna do that? How are we gonna do? Let's move it there, and it's all right. Currently we support only one image. I should add this feature as well because I want to be able to add multiple images to the question, to the images that we have in the current mark. All right. Reverse link. Oh my gosh, guys, this is my first love. I mean, love in first sight. All right, reverse link. So, like, I spent quite of time understanding this question. All right, especially it's actually both in iterative version and recursive version. Now let's try um let's try solving it in both recursive way and iterative way. So we have a linked list, right? Meaning we have a knowledge nodes, and each nodes know the address of the next knowledge package. So these are our packages. So, all right, and they hold their address. I mean, the value, they hold the value and the next address I mean, yes, next address of the next node, basically, right? So our goal is basically, let's say 1, 2, 3, 4. Our goal is to make it like that. All right. So how can we do that? Um, how can we do that? So the approach that I find very helpful is like think from the perspective of this one, right? Like if like this is the node you are processing, right? And also like this is first step, and the second step is thinking from the remaining or rest of it, rest of the rest of them, rest of it, rest of the nodes. The nodes or only nodes? Rest of the nodes. I don't know, man. Nodes, all right. What do we do? What are we doing? So imagine like here. What should we do? Here, this node basically points to this node, right? And this should, for example, like we should break this, and we should make it to here, right? And that's all. Yes. So let's see. Like we have a function, right? Like, and we will delegate this process to our sub problem, like the rest of it, meaning sub problem. We have solved one step, and the remaining steps will be, our sub problem. So func, and let's say we have a node, right? Current node. So we are making these nodes, right? Um, Next value to the null, and for the rest of the part, that we can like we show the rest of it by like calling the recursive function like this one. So this represents the remaining part basically, right? um, so func not.next represents these, actually not these guys, let me tell you that it actually represents, to be more precise, it represents the solved, the processed version of the subproblem. So like this is our original problem, and this state, like see that guys, like the arrows now reversed. All right, this is a good case. All right, we have solved. Like we imagine, like since we are a creative person, our imagination is nice. All right, fabulous. Our imagine is fabulous. All right. So we imagine, like we call, like as this method returns, like by the time it returns, it will, let's say we imagine that magically it solved and it got what we want, basically like it made what we want, so it reversed. And now um but I mean it changed the arrows directions, and what should this return? Let's imagine this returns not that, I mean not that next. All right, let's assume this returns this one. All right, this returns this node. All right, what are we gonna do with that? What are we gonna do with that? So we have now the address of 2, right? um this this 2, right, this 2 should, I mean this, it's arrow, so it's next, it's arrow. So this arrow guys here, these arrows at the moment, we don't have it at the moment, right? Let me remove. uh we don't have it, so the sub problem is this, and it the arrow is reversed. But I suppose most probably its next is still this, right? So when we call when we call this function, all right, when we call this function, And when it returns, the state we are in, state we have for our linked list is this. 2's next is 3, 3's next is 2, and 4 next is 3, right? We have this. If we had some other nodes, they already, they will already be, doing what they should do. All right. But here we have this situation, and now after this method returns, we should make, since like it returns this, we should make its next, right? We should break this arrow, and we should make, let me use green, red is good. We should make its next to our. So inside this stack frame, the node was 1, right? We are in one stack frame, and we assigned its next to null. Amazing. And we call subproblem, which is, this sub, and this subproblem returned 2 and this part. So we assign this next to um to us, to us. All right. So we created this connection as well. So we break this, and all right. Then what should we do? That's another amazing, fabulous uh, question. Now our linked list is literally looking good, meaning we have what we want. I mean, as a state, but what should we return? I mean, our linked list right now is like that, like this. Actually, it would be good if I picked color green, yellow. So we have this linked list now, but we should return, guys. Like, since this is our new um, head, we should return this. But our code, we haven't done anything for bringing this up. So now, um, now guys, what should we do? There are two ways that I know. Let me first show you the first one. I mean, the first one is, as we recursively, and also guys, maybe this step should also after this, right? Because if we process and if we make our next null, then when we go next, then it wouldn't, like, we couldn't, we basically cut the road. We would cut our road. So let me move this below of that part, right? Welcome, Antonio Morales. Welcome, welcome, welcome in. So all right, this is the way, this is the state we have right now. And to bring up the last node as we go recursively, we will have a base case. Let me pick color yellow. If we are at this node, meaning, meaning, actually it was 4, but meaning that next is null. We recognize, we know where we are by looking at if the next node is null. So if node's next is null, meaning we are at the last node, let me create, outside this recursive function, let me create node and node. All right. And when we are at this and node, we can assign that node to this so that we now have the reference of it. What are we studying today? We are, at the moment, we are solving reverse linked list problem, and we are reviewing like my notes from earlier. Basically, I have studied all of these questions, and now we are reviewing, we are adding some new notes. Yes, today is another review session. So on the side, I am also adding new feature uh, to our streams as well. Let me even fix it. Close Unity Editor, it says. Let me close it. We will set the delete code, basic, all right? Um, all right. It says close Unity Editor. All right. Restart it. All right. All right. Now, now I have stopped the Unity editor. Now, could you please ship the game? And could you please also restart our daemons? All right. Cool. Thank you, Antonio Morales. Thank you. We will restart our daemons. So wait for some time. So um, like we now saved the address of last node. All right, and um all right, so we have saved, and we will return the node. Yes, we already know what the return action. Sorry guys, we should return the node because why? Because we already said that this function, this function returned what? The next, meaning this. We said that it returned 2. From the perspective of 1, 2 is its next. We call this function, and we said that now we have, let's say we imagine we have 2 in our hands, all right? So like before typing what we should return, yes, but before writing, before typing, before coding basically this statement, we said that we imagined, because we are um, creative, right? Our creative side is amazing, all right? Without looking, without typing, we said that, like, let's suppose it returns this, all right? Next node. And we build our logic, and then we say that it returns true. It returns the node. But as I said, like these are recursive function, but the question asks, um, give me the head of the reversed linked list. So where is it? It is here. So these are like these are recursive function, right? And outside of our recursive function, let's say we have main class, right? Main method, and inside of it we will call our recursive function, and we will, I mean, um, that main method basically will return our end node. So we should create this end node here outside of recursive function basically. All right. So after our recursive function is done, it will set this variable, and our basically our this is helper function. And calling this main is not a good way. Maybe we can call it reverse linked list. All right. And I guess this is Python solution, and it is iterative. All right, we should also do iteratively as well. Um, Before that, let me check. All right, it is, I guess, building. Could you please give us reverse linked list question solution in Java, Python, and C++ in recursion? And make sure you call your recursive function as func again. There is no water in my bottle. Let's have some. Reverse linked list, alright. Here it Actually, it didn't solve like us. Hmm. We have missed a part, guys. We literally missed a part, which is good. That's the awesome voice command. Yeah, yeah, like we are now updating it. It will be better. It will be even better. Thank you, Antonio Morales. Um, we have missed the part actually where we said that we are making our next null, but I mean we made our next null, yes, and we assumed this salt, and also we made the return value from our recursive function point at us. So it shouldn't be problem actually, but this should be wrong. So let's see what we are missing. Um, let's typing down. Let's try typing down, guys. Um, there. So in Java, we said that um, let's create a class, right? How do we create a subclass? And node and integer value. Actually, node is next node, right? Integer value and our function node func, right? And it takes an argument of node. Actually, anyway, so it takes the head node, and we will type our base case, and also we are calling it recursively, giving it. Actually, I should do this like that. We are giving the next. Actually, make it next. We are giving next node, and it returns a node, next node, to us, right? And what are we gonna do with this? We have next node, and we were doing what? We were setting the current node's next value as null, and also we were doing next nodes next to us, and we were returning the node, current node. So we return what we are taking basically, right? And as a base case, when the next node is null, we update. We update what? Um, why? I don't know if it's correct, but let's have this class, right? And create our end node. I mean, declare it. And here we basically populate it with the current node. So in main, we will call our recursive function, right? Using what? Using basically we will have head node, right? That this will be giving us, and we will give this head node right? And that's all. And as a result, we should return. And no, I mean, we shouldn't do this in main, but this is the idea. Our recursive function will set this node. It will populate. So this is my answer actually, but it may be wrong. It may be wrong. So let me check after fixing this. Shipped the just game now. The two small things remain after the stream. Um, all right. Regenerate the command side so if it's retire and check-in show up on the public page. All right. All right. Um. So if I run, follow me. Very nice, guys. Very nice. So on bottom left, we now have we now show the game basically. All right. So if you guys run, follow me command, we will see your fish basically, right? Let me also, oh, we have our friends streaming. The future is not. All right, what else we have? Press enter. All right, I guess that's it. All right. Um. So now we will ask if what are we missing here? This is our solution. All right. Um, me and my friends on Twitch. All right. But I realized that we may have a we may have a mistake basically, right? Why? Because I see you are making next nodes next to us to the current node, but I'm not doing it. I'm not doing it. What I do is basically making the next as null and next node. Oh, actually, I'm doing it. Yes, yes. This code should also work. Yes. Um. So the best way to understand this is to test it on lead code, guys, and let's see if our code is working or not. Will work or not. Um. And let me log in. You can do it. We have another contest in 3 days. Awesome. Reverse linked list. So let's try typing that. So we said that we have an if statement, right? Let me make it bigger for you guys. So we said that if head next is null, right? Um, Actually, yes, this is, all right. So we should, basically, guys, we should create another method, public this node func, right? And like I will use it as our like a recursive function, and we will call this inside here, right? Like this. All right. So this function will check if head dot next null, meaning we have reached to the end. So what are we gonna do then? So we literally declare an end node, right? Here, declare, and when we reach to the end, we will basically update like a fill this field, right? With what? With head. So so this is for returning, and this function will return this end node basically, right? And here our main recursive part is what we are calling it, right? We are calling it with the next node, right? And it returns us another node. Another node. Which node? Let's call it next node. So what are we gonna do with this next node? We will make it to, we will make its arrow to direct us, point us, point to us. So what is us? It is hat. Coding Barra, welcome man, welcome in. You can run now, follow me, comment Coding Barra, and we will see your fish in our aquarium. Could you please run your, follow me comment? I have added a feature so that I won't need to switch scenes. We are changing the arrow, right? Arrow, nice. What are we gonna do with ours? We will, um, we will make current nodes next now, and we will return head, right? So basically, um, this is this is what I have in mind, but most probably it will not produce. Actually, it will, yes. So we literally return the next node. We are changing its arrow, and we are making our arrow null, right? Let's see what we will get. What do you want me to do? Run, follow me. Uh, yeah, first remove that. Run it again. All right. Now on the screen, you can see coding Barras fish. Nice, nice. Yes, yes. So, and if I run my task, nice. Camera should get more close because it is not readable right now, right? It is not readable. So for task, uh, I will end. Nice, nice. And maybe we can also add some frame so that it will look better. Um, and also change some colors, right? To red, or I don't know, yellow. Which color do you prefer, Coding Barra? Pick a color. We have some colors. You can set color as you like. And we also should give the node, right? And let's run it again. It cannot find. Uh, why? Oh, because it is inside the function, guys. I'm sorry. It should be class attribute. This is what I meant. Oh my. Sekai cannot read field next. Why? It is literal next. Because it is null. Hmm. So maybe, guys, we should add how we should add also maybe head is null, right? If head is null, what should we do? I mean, if the next node is null, it means we have reached to the end, right? Um, but if the current node is null, then should we still return head? I don't know, but let's run it. Um, Interesting. How can we debug this? We pass this argument. Nice. Null pointer exception cannot read field next because it is null. Line 23. I mean, if it is null, what does it mean? I mean, I should be able, like, I'm assigning a value, so I don't care if it is null. Oh, next node is null. If this returns null, then it may be problem. It may be a problem, but let's pick which color. Let's pick this color. Nice. So the thing is, I wonder what we are doing in the solution. This is iterative. Um, New head. Like this is another actually. Like this is the first thing I wanted to show, but then I forgot how we are doing. Here we return, I mean, we reach to the end and we return that node each time and doing this operation along the way, but this is not I'm doing right now. The approach I'm using is a bit different. Um, I don't return the end node. I don't return the last node, but um, I have another field, right? I am assigning it. I'm assigning end node to that, so we store it there. But um, let's see. Actually, I don't remember what I have said here. Let's see what I have said. This is our solution, yes, but I'm not doing it. What I do is basically making the next as null. Yes, this code should also. All right. After realizing this code also should work. Let's see. Oh my god. Let's copy this part. This is our solution and from lead code, and actually it gives an error. I couldn't understand. Like the approach I'm using here is basically I'm processing the result from the next sub problem basically, and to get the end the last node, I have created attribute in the class. So when we hit base case, like when we hit to the last node, we basically store this address in end node basically, right? um but it gives the null pointer exception, right? So I wonder how I can fix this part. I mean, let me think for 2 minutes, guys. I mean, of course, this can return null because if head.next is like, it means that, um, let's say we have reached to the end, like this, let's say this is our head, right? These are, let's say we are in its stack frame, right? And if inside the code we call it again, right? And we call it with head.next, and this head.next is null, right? So this is null. So um, in our function we define that if head is null, if head is null here, head is null, it returns head. So this function return null basically, right? So what are we gonna do with it? What are we gonna do with it? Like if we can add an if statement basically, and if this returns null, then we should return null. How am I supposed to handle this? I mean, this works. I mean, if it returns null, I mean, actually, guys, like I don't want to use this org. I mean, right? If the next is null, it means the end node, and we update. But if the current node is null, if head is null, then what should we do? We should stop recursing basically. Stop, and we are stopping recursing here. If the next is null, but if the current node it is null, I mean we should also return null. How about that? But if we do that, this will return null as well. So I mean at some point, not always. Because it's all like we have like actually we assign here, but we don't return anything. That's the interesting base case as well. Um, Actually, it should return something, right? Yes, of course. No, it should return head. So when we are at the last node, we assign this value and we return that head. All right. When we at last. How about this, man? I mean, at least this should, because is null. It says head is null. I mean, should I put it above it? Let's see. I didn't understand, guys. I don't understand why now we like our test case passed. So basically, um, we go to the end, right? We go to the until the last node, and the way we see, the way we understand we are at the last node is checking its next node. If it is null, then we are at the last node, and we assign that value, and we return this node basically, right? We return this node, but we also have a case where our node in the current stack frame is null. What should we do then? So, and this is the code that I um, fixed basically, but I kind of didn't fully understand it. I mean, I understand that we should put this if statement of where we check head is if it head is null above the if condition where we check heads next is null. I mean, the second if is for understanding, seeing that we are at the last node. But how about the first if? So, like, if the head is null, we return null. But um, I mean, let's say at 20, I mean at line 28, like the our function returned null, let's say, and we assigned null to next node, and we still again try reaching its next, basically, right? So um, so it should throw an error as well, but it doesn't. So most probably, um, yes. So I guess we don't like like what would happen if I remove this condition? Hmm. If I remove this head equals to null condition, then again I'm getting null pointer exception. But I don't understand, man. Like, I mean, if that condition is really working at some case at some point, and if I mean it returns null, and in our code, um, like we are processing the return value of func and we assign it, and we use like we try reaching its next. So it shouldn't like that. I mean it should throw an error. So could you please clarify on that? Like, guys, lead code is like this, all right? Sometimes you cannot solve it, all right? Sometimes you solve it, but you say it shouldn't work. So that's the irony, right, of lead code. um like, interesting, guys, interesting. um Muko Animo. I'm checking which other friends we have on Twitch who is live. All right. And your instinct is right that something should be suspicious. Let me untoggle, please. Why version 1 crashed and version two's null return never causes null pointer exception? You are expecting. Why version 1 crashed? A base case that doesn't return, isn't a base case, isn't it? It's just a node yourself. Alright. Why version two's return null doesn't blow up? If func returns null, then next node null and next node dot next head should throw. Correct reasoning. The resolution, like I like the term, I like the word resolution and entangled. And also there was another word that I inspectable. Let me write this as well. Resolution. Resolution. and the other one untangle. So Cloud loves using these words like resolution and tangle, all right? And also I like these words. I want to make them available in my active vocabulary, of active speaking vocabulary. So in version 2, the recursion never actually receives null. I mean, if our recursion never receives null, then why do we need to have it? And why after extracting it are we getting an error? So these are our questions, guys. Prove it to yourself with one question. Who calls func head dot next? Who calls func dot next? Who calls um every node? Oh, not every node. Yes, for example, when we are at the end, this node will never call head dot next. I mean, yes, all right, all right. Only code that survived both ifs. Hmm. Yes, that's a good way to put. Good way to put. Only the nodes that survive, like so. I like the usage of survive here. Like nodes that survives after both of these ifs, only they will run these. I mean this func, right? Meaning they are not null and they are not. Oh my gosh, this is a good way to. So I should like we should save it, guys. We should save it. Uh, there are different kind of nodes along the way in our linked list, right? So that's awesome. That's awesome. They are like guards, right? Um, surviving the second if means head that next isn't equal to null. Oh, nice. So okay. Now another question. So if I mean like we say that surviving both of these if statements, but when exactly head is null? When exactly head is null? Um, all right. So when is a func null ever called? Yes, this is my exact question. Exactly once. All right. When from one place, reverse list null. When lead code feeds you. Uh, all right. So basically, guys, in our case, I mean, in this case, in this example, we don't have it. I mean, we basically don't call this if statement. I mean, which if statement? This if statement. All right, all right. So um, let me let me take a screenshot. All right. Very nice. I have clicked, and now let me put and now add an echo, guys. Add an echo. Which echo? Oh my wow. Um, buongiorno. Right. So I spend some time understanding why we need to cover this case and realize that on our drawing notes, I haven't covered this case, right? But lead code has lots of cases to test. Has lots of cases to test, right? So yes, this is for understanding if we are at the last node. Nice. And yes, so like in this solution that Cloud gave us, um, it uses other approach, right? It basically do the operation, and it uses recursion to go all the way to the end and bring that node all the way back, while I mean while going deep, it also make this operation. So we are using another approach basically. So understanding these two got me years, guys. Understanding these got me years. So if you don't understand, don't feel any bad. All right. Uh, yeah, like the remaining part is kinda easy. We are creating and we designed. We had no. We designed our algo even before setting the return statements. All right. Let's even we still have don't frame. All right. So this is one solution, and we add nodes and the other node, guys. We can copy. Yes, this one, for example. This is literally going all the way back, all the way to the end, right? And bring that the last node, guys. Um, Let me add an echo, quick echo. Um, so maybe I should blur these two lines, right? Or like I'm trying to find a way to make this echo descriptive, even by only looking at the blurred parts. Like we can set this, and also we should take this. Yes, especially this part. This is nice. Ooh, why? It is why? It is because it is kinda iterative, right? Um, because we are doing this up while going in deep, right? Unwinding phase is dedicated for other for other purpose, for other, let's say, purpose, for other goal, for other role, like, right? um that's nice. Let's save. We add color, haven't we? All right, let's check if our voice commands will work. Email, this is a test.
This is a test.
All right. How about how about
It is break time. It is break time. This is a test.
Let's get back to work. Yo, let's back to work. We are, I suppose, back. Let me turn this off. Uh, we are back, guys. We are back. So let me first check what our friends on Twitch doing. Um, all right. We have rush codes. All right. All right. I guess we can continue. Let's check YouTube. All right. On YouTube, we have zero concurrent viewers, zero chat rate, and zero views, which is amazing, guys. Like, it means there is a room for improvement. All right, there is a room for improvement. Very nice, very nice. We can improve ourselves. So we have music. All right. So we have seen two different approaches for linking. So let's continue with, oh my gosh, find all subsets, backtracking. Let's see what we what we remember, what I remember. So the question, let's first start with, adding the questions. Um, Image. All right. Let's start with that. All subsets. All right, all right. I kind of remember it, so this shouldn't take us too long. I have solved this question before, and actually, yeah, solved. Let's paste it and let's move it to the top. Nice. And let's assign it as a question image. Very nice. Let's read it first. So we have given an integer array nums. Our goal is to return all possible subsets. So subset means subarray. No, it doesn't say subarray. Subsets, right? Um, so we can hold any number, any item we want, right? Let's try drawing its decision tree, right? Let's take a screenshot and paste it over here and try drawing this, decision tree, right? So our goal is basically, guys, um, let's say we have three items that we can pick, right? And after picking one of them, we cannot pick it again, right? We cannot pick it again. So like maybe we can have a for loop, right? And like we shouldn't go back and try adding that number again, right? um we have three number of items. Let's say we are picking one, right? And here let's say we are picking two, and let's say we are picking three. So all of them are representing like a function call, recursive function call. um so what should happen after picking one? I mean, we should first of all save it into our result, right? We should save it. So we should have a, a global hook, like a result uh, array of arrays, right? um, or list integer. Like, do they mean same thing? I mean, two-dimensional array means Like we use these two-dimensional for describing our board where we have rows and columns, right? So for example, in first row we have a list. Yes, so first row meaning this one means this. No, this. All right. First row is also a list. Anyway, um, so after picking this, we should save this as a result into our result uh, array or list. All right. We should save it. How can we do that? Or we don't need to have like a nested two-dimensional list. Like we can make use of like a like this one, right? Result. We can use it. We can add. So each time we call, we can save it here. Meaning result add. All right. Nums I, for example. But also not only nums I, but in our function call, I mean, we should also have current list, right? Current list. Meaning, for example, because we will continue making our calls, all right? And for example, after this level, in our temporary, like in our current list, we have one. So like we have one, and for example, for 1 2, we already have one, and we will try adding, for example, yes, try adding 2, right? And when we add 2, our current list will become 1 2, all right, instead of single 2. So let's remove that, and we will try adding 3, and our list will be like a 1 2, and here 1 3, right? After making this choice. So our in our recursive function we need like we need a list like this. All right. And after making a choice, we should, yes, we need list of this, because the current list, after making a choice, this current list will hold a list basically, and that list will mean one of our solution, right? All right, so that's why we need list of lists. All right, let me remove these parts. um all right, so for this part, all right, we should make like a this call like a 1, right? uh After picking 2, no, actually we don't need to make this one again. Yes, because we already covered this one, and having 2 and 1 doesn't mean anything. Like we already have this, right? Yes. So we don't need to make this call, right? So after making this call, we should start skipping this character basically, all right? All right, skip this, and we only should try adding 3, I guess, because we already have 2. All right, for 3, I guess that's all. I mean, we won't try let's say 1 and 2, because we already have, for example, 1 3 here, right? All right. um nice. So all right, and after here, for example, after 1 2, we have this 1 2, and we should have a call for 3 now, right? And we will have 1 2 3, right? And let me also add a marker to, so that we can find what we have studied. um what was the name? Subsets, right? Find all subsets. All right, we have marked the time. So we have 1 2 3. All right. So, and for this, for, oh, we can pick some other colors. Let's, which color? Which color do you want, chat? How about this? Oh, it is not visible in on black. So I'm think, oh, like, if you give me, guys, some hexa code. All right, we can add this color too. So 1 2 3, and we have 1 3. And guys, as we said before, um like here, for example, we shouldn't try 2, right? We shouldn't try 2 because we already have 1 2 3. So we should design a for loop such that, for example, in this state, right? Yes, the I value is, let's say, 2, right? Because 0 1 2. So for example, after that, it shouldn't make any call. So basically, we should have a for loop, right? And inside itself, right? I mean, I should also put the func. Like, this is our func, right? This is our func, and inside of it, we will have a for loop, right? And inside of it, we're gonna make our function calls. So, and here we will have our I, right? So we need to have like a current list. So imagine we start from here, right? Imagine we start, this is root, right? This is root. This is our root. So like in our for loop, we should pick these numbers where, like, for loop, and we should pick these numbers, and we should add them. We should add them in our current list. So current list dot add. And also we should have a timer, right, guys? Like if we spend, how many questions we have here? 50. If we spend 20 minutes for each of them, right? 1,000 minutes, right? No. Yes. 1,000. And 1,000, 2 hours is 2 hours, 20 hours. Oh my gosh. To complete all of these, we need to study for 20 hours straight. And the thing is, 20 minutes sometimes is not enough. So I should build an app where we have a timer on the screen. And also chat will be able to reset and, set it basically. We should be fast, but All right, all right. Current list, we add um, we add the current item. Basically, current item means nums I, right? we are we are adding this, and we are calling our recursive function with this list. So we add this item, right? And also we should also like I kind of remember, guys, I kind of remember. So like um we should also share this I value. Literally, the how should we call it? This I for loop iterator, basically. All right. So for this one, um maybe we can make it I, right? Maybe we can make it A, sorry. Maybe we can make it A and share this I. And we should also have this variable. All right. So our function takes the current list. We add the current item, right? One, which is amazing. And also we have another variable, and we are using this variable to start our for loop from certain index, from a certain index. um all right. And what should be that certain index? I mean, for example, we add this one, right? We add this one, and now we are calling. So if each call means one step below, right? So like for example, this is level one, right? And this is level two. So we are now in level two. We have one in our packet. So here it should start from, for example, I mean, this node, basically, right? This node. I mean, here at this level, we should only process I1 and I2, right? These are the calls that we need to make. I'm talking about these. We need to make these calls, basically. All right, we are using for loop, so our for loop should have I1 and I2. All right. um and then it should be then I plus one, I suppose, if we want it to function like that, right? So let's say we call for, like, this is I0, right? We call this, and this is I1. So when we, like, in the next iteration of this, I mean, from the perspective of this root node, in the next iteration, when I is 1, we add the 2. And also, guys, for switching to from, I mean, after making this choice to switch to that, we should also remove this, because we are using shared resource. So we should be smart. So for example, this is a state, but if we don't do anything, I mean, after adding, we make a call, and before making another, if we don't move it from our list, then this state would mean, I mean, would mean this. All right, we don't want that. So we should also not add, but what is remove? Remove from end. So how do we get end? Yes, end. Current list dot length. Is it -1? Yes, I suppose. So all right. The reason why we do this remove operation is because, as I said, for this one. All right. From the perspective of root, we are having a for loop, right? This for loop is this. So in each for loop, we add that item, and we make a call. Like, after making call, now you are here. Now you are here after making this call. and when that call returns, now you are here. All right. So when you call that, when you call that function, you are here. When you call and go inside that stack frame, you are here in this world. And when it returns, right, you are back here. Get back here. So you are here. So when you are here, you still have current list, the item that you have inserted. And also, like, we are doing this remove operation also for the others. So if we don't this, that items will stack here. So this has two roles. One for making it, making it for the, next node in the next level. All right, and making the sub problem having not overflowed values, basically, since we use shared resource. So we have removed, we are getting closer. We add the item, right? So our sub problem is solved and we have find everything, and we remove. So in the next iteration, I is 1. When I is 1, we add that item into our current list. We make a call, but I is 1, and now the call in the next stack frame, I will start from 2. I will start from 2, guys. Muco perfecto, amico. Buongiorno, muco perfecto, right? Yes. All right. So, all right. This will complete its job, and when it returns, guys, right? When this function returns, we will remove 2. This item. And now in the next iteration, I is 2 here. In this stack frame, guys. All right. We are constantly changing our stack frame. All right. Like from the stack frame of this node, now I is 2. We add this item, and also after adding this item, we should also add it to our result, basically, right? Maybe after this line, maybe we should also have like a result dot add current list, right? All right. So like this kind of counts. This kind of not sounds. It kind of looks good, right? It makes sense. There was a word that I'm trying to remember. I guess it was sound, right? It checks out. So for this for loop. So how about the deeper level? So for example, when we are here, we add I0, meaning this item, right? Item 1, and we call our function. So when we call and go inside that stack frame, now we are in this world. In this world, we made our I in the stack frame will start from 1, and it will try adding these into our current step. Nice. We will add them into our answer. Nice. And for example, when I is 1, we add 2 in our list, and we make a call with 2, and in that, oh my gosh, so this checks out. All right, now try explaining our solution to AI, and let's see if it checks out. The question was, what was the name of question? Subset. Find all subsets. Now find all subsets problem. So hello Sergeant, I hope we hope you are doing fine. And now we have solved this question, and again call our function as func, right? And it takes an argument of a list, like a current list, and the name of it is like a curr list, right? Cur list, and another integer argument, a, all right, and we will use it for assigning a different start value for our for loop, all right. Inside this recursive function we have a for loop. It's by the way, what is the name of the this I value? I mean, is it iterator? Is it sentinel value? I guess I guess it is kind of sentinel value too, right? So we have a for loop and I starts from a, and I will go, you know, and I mean as long as it is smaller than length, and I plus plus one. And inside this for loop, we have the current. I mean, we are adding the current item, meaning nums I. So most probably our array, our function should also get nums I. But if we have this array, input array, if its reference is in our scope, we can use it basically. So inside this for loop, we are adding, right? We are adding nums I, right? And then we make a call, or like after adding it into our current list, we also add that current list into our result. So result is array of arrays, meaning like a list integer, right? And after adding this, yes, after that we make a call. We're gonna make a call um, again, like a recursive call. Let's first paste it in case it fails. Sometimes it fails when the text, I mean speech, is too long. So let's not have that. And we're gonna make a call, our recursive call func, and we're gonna use our current list, and we will pass I plus one as the second argument. All right. And after this call, one line below, we are removing. We are removing. Oh, we are removing. Thank you for the sub, Ferdi Iver. Welcome. Thank you for the subscription, man. I appreciate it for 6 months. Oh my gosh, thank you, man. I really appreciate it. Here in our channel, we study lead code, we learn Python, and learn C++. We do some game development as well. And here we have our aquarium. If you like, thank you, man. Thank you. If you like to add a fish, you can run fish command. You can run fish command to add a fish, right? And your fish will be in our aquarium, basically. So thank you for the subscription, man. Thank you. I really appreciate it. It means a lot. It means a lot. So it makes me motivated to have these streams more, basically. I really appreciate it, man. Um, so here, um, thank you. So remove that part. Um, yes. All right. After this call, one line below, we are removing. We are removing. Oh, we are removing. And removing the last item in our list, basically. All right. So we are removing this. So let me also and all right. So what do we want now? Um, So we would like to check if our approach checks out, right? Um, could you please clarify on that? Let's see if we have a missing point. Welcome, welcome. Fardi Iwer. Thank you, man. Hello, soldier. Your approach checks out. What you have described is exactly the standard backtracking, yes. Solution for subsets. Pick each element from A onward. Recurse with I plus 1. Unpick. But there are two traps in its as described, and both will give you wrong output. Hmm. Not crash, but even worse, guys. Silently wrong answers. That's that's the thing we need to fix. Let me flag those first. You must add a copy of current list, not a current list itself. Why? We already we are already unpicking, so why do we need to, copy? You said we add that current list into our result. If you do literally every entry in result is a reference to the same one list of, yeah, we want that. The one you keep adding to and removing. Oh, I see. Yes, yes. I see, guys. This is important, man. This is important. I mean, yeah, we we were literally adding the same list, like we have one single current list, guys. All right, and when we call like our function basically, right? Like we will create a list of strings, right? No, integers. This we will create a list of integers, curl list, and we will initialize it, and we literally use the same current list in all of our recursive calls. All right, the same list. So when when we add a number and we make a call and then we remove, right? So since they are, I mean, this is the same list, we add, we remove, we pick, we unpick, but at the end we will have only one list in our result. So that's a good catch, Sergeant Cloud. That's a good catch. This is the classic bug of this problem. All right. Trap two. All right. So we don't have only single error, but two of them, which is better, right? Your recording happens inside the loop right after adding an element. Yes. Yes. So every recorded subset has at least one element. Yes. But all right, we can cover this case as well. I mean, like imagine um, imagine we have imagine our code basically, you know, covered all of these subsets. So we can add a case to cover this single case, right? That's not a serious thing. But empty is a subset too, so must produce 8 subsets. Yours produce 7. Alright. Simplest fix, record the snapshot at the top of func before the loop and add that. Alright, so uh yes, so no. Where is that empty list? Do you see it, guys? Do you see where we are adding the empty list? So we initialize our result array. array list, and this is for temporary current list basically. Snapshot records, like it is literally doing it inside the recursive function, and I kind of feel scared basically, guys, to be honest, to do something inside the recursive code. How can cloud dare, I mean, doing it inside the recursive function? I guess it knows what to do, I mean, it knows what it's doing, but the thing is, it adds what it gets from the previous level right away, and since it shares reference, so it adds an element and call it. It creates a new array list, guys, not the same. But if we do that, we will end up creating multiple, like we would end up creating many array lists basically. But in my solution, I thought um, we I thought we could use a single. So thank you, Sergeant, but um, I thought we could make use of single list basic, single current list, but I suppose it is not doable, right? Um, but is it? I mean, in most of the backtracking problems, we were using shared resource, right? I totally get that if we use the single current list, um, since it is like since we share its reference all over our recursive calls, and we are picking and unpicking, so at the end we would have only a single list. But to create our answer, do we really need those array lists? But I guess yes, right? Because otherwise we couldn't do it, right? Like we literally need those array lists because the structure we have is list of lists, list of integers, right? Um, I felt a bit off because, for example, in a backtracking or in a recursion question, I was using a string object as a parameter. And there I realized that in each stack frame call, we literally create a new string object. So um, instead of that, I guess I was using shared resource, right? And I was creating the solution for the kernel stack frame and saving it into global hook, global variable basically. But here, I guess since we need to have separate like a real array list standalone, right? We are initializing new array lists, right? So my intuition comes from that example because I felt like I need to use a single temporary basically current list. So I shouldn't initialize new array list basically. But I guess in our case we should, right? Could you please clarify on that? So that's where my you know intuition comes from. I was too afraid creating unnecessary array lists. I created the wrong solution, but that's all right. Um, your intuition is not off at all. In fact, you're already doing exactly what your intuition says. The two things you are comparing are the same pattern. Let me name the reframe. one shared buffer for the journey, one frozen photo per answer. Look at your own code again. There is only single current list for the buffer is created exactly once in subset, and every recursive frame shares that one reference. Picking and unpicking into it. That's the shared resource we are used to from backtracking. Nothing changed here. I guess something changed. A new array list current list. Calls are different thing entirely. Alright. Let's check the solution. Where is it? Um it says we are using. Oh, alright. Guys, understanding is enjoyable, alright? I thought we are creating new current list again. So no. We have one result, alright? And we have one current list, I suppose, yes, which is this one. And we are using it like we are literally using it, right? For like a utility jobs, right? We need a place, we need a bucket to add, to pick items, unpicking, like basically creating an answer for the current sub problem. And we need to put that sub problem, maybe snapshot, the word it used. Snapshot, is it snapshot? But for that, we are initializing a new array list basically. All right. Um, yeah. All right. So what did we learn? What did we remember from this question? We should save this. Um, all right. First one is the current list. I thought we should create current list only once. And then after learning that um, we should Snapchat each answer. I thought we are creating now multiple current lists, but no, the current list is static, there, concrete, but we are using it for snapshotting, right? Um, all right, let me paste it, I suppose. Let's copy and paste it over here, and let's create an echo. Let's even assign some colors. And the thing, guys, is the way we snapshot current. Actually, there is also another nuance, guys. Um, we literally we are immediately adding the current list that we got from one level above, like from our parent. We are immediately adding it, right? But don't worry, because we add its reference basically, right? So we can add an item. Yes. But actually, I don't understand. I mean, we add that item, so it is there. But we edit its snapshot. Hmm. I guess it kinds of work. Okay, shifted. I mean, let me let me take a screenshot and show you guys what I mean. Let's paste it over here and also like that one. Right. So as we call it right away, for example, we add the current list right away. So the current list is empty right now. All right. So now, oh, you don't. All right. So maybe how can I turn this off? Let me. What was the name of this? Hmm. All right. So yeah, it is much better. So the current list is empty. We add this as an answer because yes, we need it. So in the for loop, guys, in the for loop, I is 1, we add the current item, meaning, let me use another color, even maybe this color. No, we add this item and we make a call. All right. And for example, in this sub problem, current list will include that number. All right. We add this. So as we add this number into current list, and when we call the recursive function here, for example, in this level, right? Since the first thing we do is, you know, adding it as an answer. So before even making these calls, we add this one, right? This as an answer into our result. I mean, as an answer, as a result, basically, right? Into our result. Yes, this is where we do this. This is where we do this. All right. Because I thought, um, yes, because the place where I was adding them was here. After this line, I was literally adding. So, but how about that? What would happen if we do that? I mean, we add the current item 1, we add the current item 1 into our current list base, like current result. I mean, yes, current list, and we add that current list right away, like right after that line. What would happen then? I mean, we add this item and we add this. Yes, like we could do that. We could do that. So like, I mean, this is for making, I mean, this is for adding this into our result, but we can handle this. We can handle this case outside, all right, outside of our recursive call, right? Um, so let me think for a second. What would happen? I think that shouldn't be a problem. Uh, that shouldn't be a problem if we cover this case. So let me ask. Thank you, Sergeant. And I want to set the combinations problem as well. So keep it in your memory and remind us. But the thing I wonder is, I mean, I don't want to add this right away, right? In our function, recursive function, we literally add the current version of current list, like a snapshot of current list into our result right away. But instead of that, I want to do this, like I want to do adding the current stack frames answer into our result after the line where we add the current nums I into our current list. And I want to handle this empty array and empty array outside of our recursive function, all right? Can you please design such a system and give me the code? Give us the code. Like, so it is Wednesday, right? Yes, so Wednesday. So for today, I have 3% of daily limits, weekly limits left. If I want to, like, I mean, on Sunday, guys, I wanna have on Sunday or Friday, or in both of them, on both of them. Like, I wanna have, let's say, 15 hours, maybe 20 hours long stream, right? What do you say about it? What do you say about it? So for those days, I should spare some, you know, some of our weekly limits, basically. um let's see. So yes, I guess we could do it, guys. I guess we could do it because the thing I have in my mind was literally that this one, right? um so as a hint, um to to cover to cover empty array case, we have this. All right. It would be awesome if I start my own timer as well because I need to keep track of time. Nice. Press enter. I guess we already have. Press enter. So the other part we have is like there is nothing too complicated about these. Maybe that part. All right. You can save it and let's take a screenshot. I mean, this recursive function doesn't fully solve our problem standalone because it misses the empty case and empty array. I mean empty array case. So basically, um, but we can handle this like this one line. All right, like I'm doing this because guys, there are some recursive function. I mean recursive problems on LeetCode on trees basically. So like I mean you delegate a sub problem to recursive, right? It brings you an answer and you process that answer and coming up, I mean, with the correct result. And we have this in some popular algorithms as well. um so recursive function solves some part of it and you iteratively do some other remaining parts. For this problem, I mean, it is doable for us to, design a single function, single recursive function, and it returns the answer right away, right? But there will be times where we won't be able to do this, where we will need like a recursive function as well as the iterative steps, basically, right? Um, yeah, but again, we should be familiar with doing both of these, right? But like I'm not I'm not relaxed while adding a line into recursive function because it changes, like it has possibility to change things very drastically. So I tend to not to do that. Let's take a screenshot. Let's paste it. All right. Let's add it into our echo nodes. Echo, not echo. Echo nodes. Yes. So this is what I mean. Adding this case as an result right away. This is me saying how bad are you. um all right, save it. And I want to continue with combination but to spare some, I mean, our energy, guys. Let's see another question. So by the way, I really wonder um what we'll see. All right, in browse to some is also we should add some like a sort by creation date, right? Because I guess it is kind of random. Climbing stairs, climbing stairs. Where do we have our subsets? Yes, I guess it sorts by mark name. We should definitely add the filter here. All right. Now it is time for merge sort, guys. Merge sort. What do we, what do I remember? What do we remember for merge sort? Hi, welcome in, Saron. Welcome in. Now we're gonna we're gonna review merge sort. What do you know about merge sort? And also you can now run follow me command, Saron, and we will see your fish. I mean my fish in this case, but on left bottom. Alright, I added this feature, and isn't it amazing? You can run this command as well. I hope I didn't disturb you yesterday. No, man, no, there is no. Like, we've done 0 out of 4. Um, see Orkan, I suppose. This is your newest fish. Um, no worries, man, no worries. Even though you did that wouldn't be any issue, right? I enjoy your companion. All right, it is good to study together. I enjoy studying together, basically. All right, you are kind, by the way. Thank you. So now we're gonna review merge sort. And let me run hunt command, but I guess I was in peaceful. Oh, I'm not even that big. Actually, I should be able to select fish, so I will add this feature as well. Even 9 times. Oh my gosh. How about let's first feed my fish a little bit using fish 5 times. All right, we can redeem that. Let's feed it again. Grow. All right, let's try hunting. I wonder if our overlay. Yes. All right, in hunt and in follow, what did I eat? Burning fat. All right. Houses. All right. Houses. Good. All right. So the thing about, all right, so I can also add a marker, right? Marker merge sort. So for merge sort, let's go. I am 1-7 voice streak. Oh my gosh, man. I appreciate, man. I appreciate it. Thank you. Thank you. We should like I should prepare some gifts for Strike. Yeah, yeah. Thank you, man. It is good to have you, man, in our streams. So um so for merge sort, basically, guys, like this is sorting, basically, guys. Let me tell you that. Let me tell you that it is sort. So our goal is basically, like, we have like a numbers, round numbers in random order. We're gonna sort. How? Merge sort does this. All right, we have func. All right, and we will make this call, like we will solve left half, right? Meaning left, let's say left. All right, and we will expect left part be sorted. All right, for example, after when after this function returns, we will have like a left half sorted, basically, right? I have a question. If I do the feed a fish, it doesn't feed my fish all the time, right? No, only single time, only once. 7 streams track. Oh my gosh, man. It only feeds your fish once. Petal, I guess, with petal. um so we expect the left part to be sorted, all right, and then we will sort right. You guessed it right. We will sort the right part. So imagine we have, let's say, 1 2 3 4, and imagine uh actually, not, let's not make it this one, but let's say let's say let's say like a 6, right, 8, right, and 10 and 15, right? We sorted the left part, and this is left part. And after calling this function, we will have the right part sorted out. And let's make the right part uh like this one, right? Yes. So our left part is sorted, right? And our right part is sorted. So I like this post order traversal, right? You basically call your left heart and you basically imagine, like, since you are creative guys, it's like we are creative people, right? um we imagine somehow magically we solve sorted left part, and magically we sorted the right part. Now what we are gonna do, all right? um like after calling func left, after calling func right, I mean left half and right half, right? We will need to create a new like answer array, right? And let's say we have pointers, like pointers from here, from here. As you guessed it right, we will compare these two and we will pick the smaller one, right? And put it into our result, right? We have we have we have pointer one, pointer two, compare, take the smaller one, put it into our result, right? This is our result. All right. Um so and after that we should move the smaller one, right? One by one. Um so actually instead of removing, let me take it and move it. Amazing. Now, as you guessed it right, we will make this comparison again. And we will take the smaller one, put it into our result. And also maybe I can pick maybe I can pick a new color, right? Maybe like that one. But it should be different than that one. Like a maybe like that. How about that? So let's remove here, and we picked 1 and we picked 4, and now it's time for us to move, since we process we use, right? We're done with P2, right? And now we move it. Again, it is smaller. Put 5. Very nice. Move your pointer. Now you compare, and now the number that pointer 1 points is smaller. Oh my gosh. Let's pick that 6 then, right? We we have a logic to pick the smaller. So we pick the smaller. After picking the smaller, move basically that pointer. Amazing. So put 8, right? 8, since 8 is smaller, move pointer 1. Amazing. Compare, 10 is smaller, put 10. Even better, let me remove that part as well and add result. We put 10 and we moved our pointer, right? Which is amazing. 15, and now 11 is smaller. We add 11 and we move that pointer forward. Amazing. So we compared these two, and 14 is smaller, which is amazing. And now guys, this is the case. Now we need to use now we need to use our cognitive energy. So after adding 14, we will move our pointer, and our pointer now is basically beyond the length. I mean, it is in our length, right? This is the last location, so it will stop. But how about that? How about pointer 1? Actually guys, to make it more clear, let's assume we had another number, right? Actually, could we have another number? I mean, we divide like a half. Can halves have different number of elements? If so, which half would get? That's a brilliant question. Let's save it. Can halves have different number of items? If so, which one? All right. Let's assume we have 20, right? So, and our pointer one is here. So now we need to use our cognitive energy and say that we need a while loop, right? While p1 is smaller than length, right? Yes, because length minus one is the last index, and if it is length, then we can stop. All right. If it is smaller than length, we should move it, but I mean, and also we should move it, and also even before moving it, we should add what it points to into our result, meaning like result at at um at nums, you guess it right, p1. So because like we should add this into our result, right? And we should add this into like, so it means that for for all the remaining elements, right? After making these comparisons, for all the remaining elements, we should add them into our result. And Saron redeemed drink water. Let's do that, man. I have little water in my, you know, container. I am thirsty. Thank you, man. Thank you. I appreciate you, man. I can't even spell, but I understand. I understand. Like I don't spell thirsty correct most of the time either. So there is no issue with that. Like it is not cold. I would prefer ice in it, but it's water anyway. So this is the source of life, guys. So thank you, man. Thank you. I appreciate. I appreciate your redeem. So we add, like we are adding all the numbers we have left after comparing. Like if one of the pointers can, may end before the other. All right, we don't know which one. That's another thing. We don't know which one may or may not end before. All right, so this is for pointer one. I mean, if like since we don't know, we will run our function. I mean, run some function for each of them. So this is for p1, and we will have while loop for p2 as well. And actually, this length comes from left part. I mean, left part's length, and this is right part's length, right? And we add them, right? We add nums p2, right? And p2 plus plus. Very nice. So after these while loops, we will cover. I mean, we basically cover this case. So yes. So another thing to remember is that how do you halve an array, right? How do you decide? For example, you have this array, and how do you plan to divide it? Because we need indices, guys. We need indices, right? How do you divide an array into half? how do you generate your start and end indices, right? For both of, oh, it is already sorted. No, we need original array. Let me create an original array as well. Like this is sorted. So let me create an original array, random. All right, let's use 4. Let's use 11. Actually, no, we cannot use them randomly. I should randomize these ones. So, uh, yeah, yes, 20, 6, 8, 15, 10 is the first half. The second half is, let's randomize it, 1, 5, 4, 11. All right, so this is our original array, right? This is our original array. How do you plan to divide it into half? So how many elements we have? 3, 6, 3, 6, 9, 10. Wonderful. I guess this point is the half, the middle point. We could have even odd number of elements as well. So we need different cases for dividing odd number of elements array and even number of elements array. But here in our case it is even. So but we should learn both of them. For even number of elements we should like we have like a start point, right? An end point and midpoint. How do you calculate mid? You could calculate mid by, right? I mean, take the difference, divide by 2, right? Divide by 2. Take the difference. So end minus start. Um, Actually plus 1 is the distance, and if we divide that 2, so this is one way, but it may produce overflowing, I suppose, right? If the length is too high, no, yes, I don't know, I don't know. Um, like there was a case where it causes overflow. We can ask this. We can ask what that is to remember. But other way to calculate mid is start from start and add a distance of the way the distance you should go to reach that part. The distance is actually this one, right? I forgot how we calculate mid. Mm, actually, yes, like and actually that one and minus start. This is the start point, and this is how much distance, how many distance I need to go. I'm watching since 15 minutes and didn't understand any. You don't need to. Like we are solving merge sort. You can check it out. Um, there is a recursive part where you sort left part and right part, and after sorting both of halves, you basically merge. I need to practice. Yes, yes, of course, of course. Don't feel any bad about it. All right. I spent tons of times understanding recursion and tons of times on merge sort itself as well. Now I'm just reviewing. All right. Just more practice. Yes, of course, of course, of course. Basically, we sort the left heart, we sort the right heart. Now we merged, but before sorting left part and right part, we need some indices to give our recursive function, like a start. So we need basically mid, like a start mid and mid end basically. But I forgot how you calculate mid. Is recursion where function call itself? Yes. Yes, of course. Function calls itself again and again. We don't know how many times, but we don't care. But the recursive IDEA solves many problems. This is very useful, and of course, for dynamic programming and vectoring and graph and trees, you should get familiar with it. Otherwise, you won't be able to solve those questions. So if you want to get good at lead code, code forces, what is binary search? That's a brilliant question. Binary search is looking for a number. Like let's say we have this array, and let's say you want to find 5, and if it is there or not. So basically, first you sort your array, right? And after sorting, you check the middle element, and you are checking if the middle element is, you know, equal your target. If it is, then you return. But if it is not, then you have two cases. If it can, your target can be small or high. Based on this comparison, you reduce reduce your search space. You reduce your search space by half. This is why it's called binary. So let's say your target is 5, but the middle element is, 10. Then you need to shift your search space to the left where there are smaller numbers. So basically, you're gonna make your search on the left side. This is binary search basically. And in binary search as well, there is a calculation for mid, but I forgot how we do it. So even in a merge sort as well, I guess it was this what um, we may have like odd number of elements and even number of elements, and our formulation should support both of them. I did 2 years ago linked list. All right, linked list also, yes, for also, I mean, linked list, you should also need to know recursion as well. Like for some cases, you can use iterative approaches as well, but it helps. Recursion helps. So let's check, guys. Like I don't, like we need to be fast. How to calculate mid of an array. Let's copy and anyway, let's paste and let Google AI answer. Are you solving in C or Java? I'm using Java. Actually, yes, this is the formula. Start plus. uh, Actually, yes. Like this didn't add one. All right. This is the point I missed. We don't add one. Actually, the place where we add one is for calculating distance. To calculate distance, you basically and minus start and plus 1. This is the formulation for distance. Right? This is the formulation for distance. But for calculating mid, we don't do that. All right. It's good to remember those, review those. So we don't have this one basically, so we can remove it. All right. So this is how we calculate mid. So after calculating mid, so as we said, like we will, sort the left. For sorting left, we need indices. First index will be start, and the next one will be mid. And we calculated mid by doing what? By adding these values to start, right? Start plus and minus start divided by 2. And I wonder if this function works for even an odd case. Mid. So this is for left part. And for right part, we will use, guys, you guess it right, like this is the first, this is the left part. And the right part will be, guys, as you guess it right, mid plus 1. So this is the right part. So green mid plus 1 and yes, these are for left right part. Amazing. So after that, we will do this operation we have written here, and actually we haven't written it fully. We have written the part where after finishing, I mean after one of our pointers finish. But for comparing side, um, which numbers we how do we compare with? Now let me write the code for comparing. All right. Um, let's for comparing and putting them into um, array basically, right? So what do we do? Um, we have an if statement. If the number at pointer 1 is bigger, actually we are looking for smaller. If it is smaller than the pointer 2 value, we should have an array like result array basically, right? And also we should have a counter, right? Result. Actually, we don't need to have a counter because this if we are using array list, it automatically handles where to insert. Result at which value? Smaller value, of course. All right, but if in else case, right? In else case, um, it means p2 value is smaller or equal. So then, in equal case, so we cover the equal. I mean, um, there was even word for that. When they are equal, we pick p2 nums p2. All right, and we also should increment the pointer. So when we add, so p2 p1 value, we increment the pointer. When we add p2, we increment this pointer basically. All right, this is code for basic comparison. And when we have remaining elements, we will use while loop. And yes, and even before that we have this func. All right, let's try describing what we have to cloud, and let's see if we are missing any point or not. Hello Sergeant, we hope you are doing great. And now we are solving merge sort, and we should first of all calculate our midpoint, right? Like we have start point and end point. End point is length -1, right? And midpoint is calculated by summing start plus in parentheses and minus start closing parentheses and divided by 2. I wonder if this formula of course we know this formula covers even an odd case, but um, could you also show you in another example how it handles? So we, after calculating our mid, now we will call our recursive calls, right? Func. We should give which part it should sort basically. So it should sort from start, comma, the mid, right? So we should give these parameters from start to mid. It will sort. And below this line, we are calling our recursive function again, and this will start from mid plus 1, and the end point will be end, basically, right? And after calling these functions, now it is time for us to basically merge. Now it is merge case, right? So for merge case, we need pointer 1 and pointer 2, right? And let, let me first paste it. This is open code CLI, right? No, it is a cloud. I mean, cloud. This is cloud. This is not open code. This is I'm using Ghosty CLI, like a Ghosty. Ghosty. Um, like Ghosty terminal. Inside the Ghosty terminal, I'm using Cloud's own, Cloud code basically. Like Ghosty is open source, and I will add some new features as well. For example, to change the color of the terminal as well. Oh gosh, what triggers this? I don't know. Maybe the same key. Like it is open source, so you can add some new features on top of that. What were we saying? So we have pointer 1 and pointer 2, and we should have our array, right? Like answer array, and we now will build it using pointer 1 and pointer 2. So after sorting those halves, pointer 1 will start from start, and pointer 2 will start from mid plus 1, right? And it will, I mean, they will, yes. So we now have a if statement, and if in that if statement we will compare the value at pointer 1, right, in in left part, in left part. Left part means actually no, like we have single array, so left part means our start index is 0 basically. um and we are comparing the value that pointer 1 points and pointer 2 points, and if the pointer 1 is smaller, then we are adding its answer to our result, right? And we increase the pointer 1. And in the else statement, meaning that nums, I mean value we have at pointer 2 is equal to or greater than pointer 1's value. So then we add pointer 2's value into our result, and we increase our pointer 2. And after doing that, actually this if statement should inside a while loop, and while both of our pointer 1 and pointer 2 are smaller than the length of their halves, we should do this operation again and again. And when we go outside of this while loop, we may still have remaining parts. All right, for those remaining parts, we need another two, I mean another while loop, actually not one, even two of them. Let's paste this part as well. And we will continue describing. So after that while completes, we may have like a remaining, right? Like a remaining, maybe there is a term for it, like not remaining, but we can call it remaining, remaining parts. So if p1 is still smaller than length, then it means we can use our pointer 1 and add those numbers into our result basically, right? And inside that while loop, we increment our pointer, and this is one of them. In the second while loop, if p2 is smaller than the length of the right half, we add the numbers that are left there, right? Using pointer 2, and we increase pointer 2 value. So this is my solution. Could you please check if I am missing a point or something? And also another thing is that for calculating mid value, or yes, for mid value, like there was a trick where we cover overflow situation, right? Because like I remember something that for calculating mid, for most probably, if we use it maybe like a summation, and like summation, I don't know, we may end up having overflow. What was that thing? Was it related to calculating mid, or was it related to calculating distance? But distance is easy. I mean, for distance, and minus start plus 1, right? Let's see the answer of our beautiful, amazing, fabulous cloud. Astonishing. Astonishing, and there was other word. No, enormous, but cloud is not enormous. There was another adjective. Let's see. Hello, soldier. Your merge sort is structurally right. Yes. Like if it started with that, guys, it means that we have we have a missing point. All right. Split admit, recurs on both hulls, two-pointer merge with drain loops. Oh, that's a nice word. Drain loops. That's the algorithm. But your description has two. Oh my gosh, that is sad. That is very sad. That is very sad. Real missing pieces and one bounded you stated in a way that will buy. Then I'll saddle the overflow memory. Alright. You're remembering correctly, and it is exactly about it. Alright. Let's see. What is missing? The base. Yeah, we can cover base case. Your microphone and camera desynchronize. Desynchronize. Left. Right. What do you mean? Wake. Up. Looks perfect to me. You mean it should be like that? Like, I mean, I can like we can remove this mic from out of sight. Uh, like even better, I can put it inside my shirt. It's like your voice coming from behind. Actually, we have voice canceling mode on. So, oh my gosh, guys, I have lost my microphone. Hold on. No problem. See, like, how about now? Wake the up. How about now? Like, is it? I mean, does it sound better? Now I turned off the voice canceling feature off. You should be able to hear me better. But then outside sound can also get up. I mean, get caught. So how about now? Is it any better? Is it any better? All right. Thank you for heads up. Thank you for the heads up. What missing? The base case. Actually, we have never mentioned about any base case, because I don't like the base case idea at all, right? Because forget it. We will cover this now, right? We will cover this. Copy back. You built answer array but never said where it goes. I mean, outside of our recursive function, like let's say like we have our recursive function, right? And we handle those stuff, and outside of that we have result, right? And we are basically storing hold on, it may telling us something meaningful, like basically, so basically we called our function left right, we called for it for right half, amazing. Now we have basically, like using a while loop, we compared those pointer ones and pointer two. We so like we have an array, right? We have an array, and after calling these two, their half, for example, left half and right half is sorted. So now we are comparing those values, amazing, right? Pointer one, right? Pointer two, and we have another array, like we have result array, right? Yes, result. But the thing is, we are doing this inside the recursive function. So if we use this result array, and since it's shared resource, right? Like a result array, if we are writing into it, actually no, that wouldn't cause any problem, because this will, like, this process will be the last thing that we write on in, I mean on, oh my gosh, on result, right? On result. Actually, we don't need that anymore. On, you hear me very well, right? On on this result. So this shouldn't be any problem, but I didn't get what Cloudy said. Copy back. You built the answer array, but never said where it goes. I mean, it doesn't go anywhere. You merge into a temporary array. You merge into a temporary array. I mean, we are missing a point, guys. We are missing a point. We sorted left half, we sorted right half. Now it is merge phase. We are missing a point. This is a merge phase. Very nice. But how about the child? I mean, you merge into temporary, but the halves live inside the shared nums. Yes. I mean, we have nums array as well. It isn't random. So let's remove that. We have nums, right? And this holds our real, random array, basically random numbers, and we call it we call it we sort. Where do we hold actually the sorted halves? That's the question. Where we, like, this is correct, but we need a place to store the sorted half, right? So that function should return a list, maybe list temp, temp list, temp list one, and this should all, actually this shouldn't be like that. Like, we are doing it in place. Yes, we are doing it in place. I mean, we are manipulating the original array. Yes. What are you talking about, Cloud? We sorted. I mean, sorted means we have done this in place. So our nums array is now sorted. Sergeant hallucinate. No, no, no. It is most probably correct, and I'm missing a point, but I'm trying to understand which point I'm missing basically. Um, so nums array. Basically, this is nums array. We sorted left half and right half in place. Actually, we are doing. Oh, thank you for the follow. Try Namakai. Welcome back. I hope I pronounce your name correct enough. Try Namakai. Well, welcome, and thank you for the follow, man. Thank you for the follow. We are analyzing the merge sort. We coded basically merge sort, but apparently we are missing a point. You merge into a temporary array. Where do we merge? Oh, the merge phase is here. Yes. Oh my gosh, guys. Let's try coding it out, and it will be easier to see, guys. All right. Um. So let's even remove that part. It's about understanding relation between data. It is about after sorting left half and right half, in the merging phase, we are merging and putting them into a temporary array. This is amazing. This is good. But how this will work in our like a children stack frames, basically, all right? This is our parent, our root stack frame, root perspective. When we go, for example, like we have this array, right? And we take the, for example, left half. But in that half, we go again into a new stack frame, and in that stack frame, our new array is this, and we basically cut this half again, and this becomes another array, and this part becomes another array. So we cut them too. So this cutting and cutting half continues, yeah. So and after some point we start unwinding and building. But the thing I'm trying to understand is like in merge phase, like this is why I need to implement basically. We say that we sorted left half and right half, and in the merging phase, where do we write? In temporary array. But what are we gonna do with that temporary array? I thought we need another global result to save this, I suppose, because we will go into merging phase in these in these subtrees as well, right? That merging phase will be here as well. So if it is, I mean, even if it is temporary. So like I'm trying to understand after merging phase from, let's say, right sub3, how it affects the main. Yes, I don't see it clearly, so I'm trying to understand that part. So let's say void punk punk, right? And actually we can call it merge. For merge sounds good to me. What are we gonna do with that, guys? What are we gonna do with merge? Actually, let's call it funko, right? And we are calling it for left half All right, and we are calling it for right half, and we assume those halves sorted. Now, merging phase. How do we do that? We need, as we said, we need a while loop, and in that while loop, we need like an integer pointer 1, right? And integer pointer 2. We should make them start from 0. All right. Um, and while oh my gosh, while I cannot use my while p1 is smaller than the length, left part's length. How do we calculate left part's length? Um, Also here we should calculate our mid, meaning like our function should take integer start and integer end, let's say, right? Mid will be calculated by start plus subtracting end start divided by 2. Or we have mid, and we will call it with start comma mid and mid plus 1 and end. All right, we sorted left half, we sorted right half. In the merge phase, as long as p1 is smaller, than the length of left half. How do you calculate the length of left half? Left half start point is start and end, so we should calculate the distance by mid minus start plus 1. This should be the distance, the length. All right, as long as this is true. So yes, this is what I'm talking about. So we need outside of our function, we need like a list, right? List to store, list of what? Mm, list of integers, I suppose. List and new, not list, but the implementation, and implementation is like list is interface, and array list is concrete class, a class that implements that list, right? List. So we should add that item. Which item? The item at pointer 1. At item at pointer 1. We need nums array too. Where is our nums? Our input is integer input, and it is nums, and I guess it is like, let's say like this one, right? All right, it is our nums, and I guess it is not the correct way, right? Or is it? I don't know. Should I use new? Anyway, we can look that up. We have our nums, and we should add which number? Nums. Actually, no, nums is not random. An array is mutable, right? We can change, yes, but if we are doing this in place, very exactly, we are oh, now I understand your name. Trying to make uhi. What is uhi? Trying to make you high. Something like that. I will get familiar with these usernames. Trying to, right? Trying to make you high. Most probably. Um, so the question is, if we are doing this in place, let me write it down. If we are doing this in place, where exactly we are manipulate, updating the nums. So, oh my gosh. If we are doing this in place. So the goal was we sorted left, we sorted right. Now it is merging phase, right? We need to compare the characters and pick the smaller one. Pick the smaller one. So we need another condition here, and P2 is smaller than the length of left half. Calculating the length of left half. Mid plus 1. All right. Actually, to make it even more clear, integer length left half. All right. We can put this so that it is more clear. Length right half. So we can copy this part. Yeah. Yes. So we can remove this left half. All right. And length of right half. All right. Let's add some spaces as well. As long as they are smaller than their lengths, we need to compare first. Compare what? Compare P1 and so if the value at P1, right, is smaller than the value at nums P2, which one is smaller? P1. So we add what? Like we add P1 value to where? To our result array. I mean, like maybe we can call it like a result, right? Like I'm missing a point, and this is quite important. And like result dot add nums p1, right, and increase p1. All right. Else we will add p2. Trying. I thought you were focusing on the array, then suddenly you mentioned my ID. Yeah, like I don't know. Like I'm trying to code the merge sort from my memory basically. Yeah. Like because I a new follower came earlier and I pronounced her name very wrongly. She didn't say anything, but after a few streams, I checked its username again, and it is totally different than how it is supposed to pronounce. So that's why after that I am paying attention to the names of our viewers' usernames. Result P1 like P2, P2, and increase P2 plus plus. All right. So while they are good, we compare them. We basically put the smaller one, and now we need another while, like two while loops. This is for the remaining leftovers. That word was leftovers. So for leftovers, yes. So we need two while loops. Like I feel like I kinda remember, let's say 90% of it, but we are missing very critical point, and let's see what that is. While P1 is smaller than the length half, right? Yes, but as long as it is smaller, less than, we will add that one, yes. to our result. Amazing, amazing. I mean, if it is. And while P2 is smaller than length right half, and I misspelled, but anyway, right half, and P, we like we will basically copy this part and paste it, right? And P2 and P2. Nice. So what do we have now? I mean, we like still we didn't manipulate the original nums anywhere, but the code expects I mean to to be changed in place, but we didn't we didn't do it. We didn't change it in place, but the code expects. I mean, when we call this, for example, we say that, I mean, after that this method returns, we expect that it sorted the original nums array, I mean left half, and it sorted the right half, right? And then we built all of our function on top of that, but we are not changing nums in place. Where should we do that? Where should we, like, we are writing the result here, but we don't swap, or what am I missing, guys? What am I missing? Like, we have an array. Like, this is like building a car, right? But forgetting adding a gasoline, basically, right? Like the most important thing. Maybe creating a car, but forgetting adding steering wheel, right? We have all things we need, right? This is amazing. Like when you look at the real code of merge sort in Java, you'll see these, all right? Basic, right? Amazing, amazing. But we don't update, we don't manipulate the original array, so we cannot expect this function to return. Actually, we don't even use its return value. Why? Because we expect the original, yes, like we are literally expecting nums to have the correct numbers. I mean, to have good numbers, sorted numbers on left half and on the right half. So for us to be able to do this comparison, we need to update nums array, manipulate the original array. But where is it? Where? Where and how am I supposed to change? I mean, with what? I don't know, man. Let's see what AI says. You merge into a temporary, but the halves live inside the shared nums. Yes. After merging, you must copy temp back into num. Oh, nice. Nice, nice, nice. I mean, I needed these 2, 3, 4, 5, 6, 7, 7 words. You must copy temporary back into. So now I should also determine where is our temp. And maybe I should create a helper function to override our nums array. We should override our nums array. Let me take a screenshot. This is merge sort, right? Yes. Come on. So while reviewing and while retyping the merge sort, I realized that I have everything I need. Like I call like a func left, I mean func left half, func right half. I expect them to return us a nums array, which is shared source again. And the left half, I expect left half to be sorted, right half to sorted, and then I'm doing the merge phase, which is amazing. Everything goes amazing. And And after that, in merging phase, we have while loop. In while loop, we compare two pointers and get the smaller one, put it into result. Like this is another blurry part, like where do we store our result. And also we have another two while loops for the leftover pointer one and pointer two. This is amazing. But the thing is, how do we how do we how do we exactly manipulate or change the original array? I don't remember. I don't remember, and I don't see anywhere. I mean, I don't see any place where to do it. Actually, why? Because, for example, in the previous question in backtracking, not backtracking. Yes, in the actually yes, in subsets problem in the solution. I mean, in the solution of cloud basically, it added the adding the result, I mean, adding the current list into result array list on top of, I mean, above the for loops, right? So I kind of sidestepped that and I covered that adding a, empty list outside of the our recursive call, all right? Because I literally skipped that case basically. So I feel like adding a function above the recursive function call and below the function call, like maybe we should get I mean maybe we should practice it more, because in this question, if we want to manipulate our original nums array, where should we do? I mean, above of our function calls or below? If it is below, is it above our while loops or after or below our after while loops? So yeah, so these came up while I was trying to type the merge sort. Let's see, man. Let's see. Um, After merging, you must copy temp back into, like, uh, so we may need to have a, a utility method, guys. Utility method, all right, to manipulate, to change the original array. Skip this and the merge works evaporates. Yes, I like that word. Yes, yes, I like that word, because even in the previous vector, like a subset problem, we had this issue. We had this issue. We used I used same temporary array. We were adding and like a picking unpicking characters over and over again, and we stored that same temporary array basically. um, I mean, not temporary, basically the current. And at the end, we had only like single array list, and it will be empty basically. So that's why we needed to create new array lists. We needed to instantiate new array lists and then store them inside our result. Yeah. So for here, I mean here, skip this and the merge evaporates. The parent level would merge the same. This is the most commonly forgotten line. Like, is this really the most commonly forgotten part, guys? Do you really believe that? Or AI just, uh, telling that this for making me feel better about myself? Because AI does this, man. I strongly believe that this message, I mean, there are lots of people who solve this message already. Because in the answer, there are some parts it, copies and showing everyone basically. AI does sugarcoat stuff. Yeah. Exactly, coding better, exactly. And oh my gosh, we don't have two things missing. We have three things missing. Your wild bounds, not the length of their house. There are no separate half arrays. I mean, using start, yes. Both halves are virtual regions, yes. Like we know that, alright. Um, Inclusive. Your drain looks like one. Your term remaining parts on minor point on ties. Yes, this is the word I was looking for. On tie. Take from P1. Like I was like on tie. We are taking from P2, and it says on ties take from P1 for plain inst the output identical either way, but taking the left element on equality is what makes merge sort stable. Oh my gosh, guys! Like we are learning again, and cherry on top is stable. There are lots of sorting algorithms, and you will see that some of them sometimes on certain cases they are not stable. So what does that stable mean? So this is what it means. I mean, kind of, I mean, this is the first time I've encountered in one of my solutions basically stable. Equal elements keep their original order. Free to do, and it's the property interviewers ask about. All right, all right. Let's continue. The code in your template. Let's see, guys. Let's see. Sort array func. Yes. Forget about base case for the sake of time. We calculate mid. We call for left half. We call wonderful. And we merge. All right. At the merge part. Do we have another? No, we don't. We don't have any other utility. So in the merging phase, what are we doing, guys? Let's see. Um, like I don't know why are we creating a temporary array. Our P1 is start, yes. P2 is mid plus 1 because it is the start point of right half. And we have something like K, I don't know why. And also in the first while loop, also check, I mean, see that it is equal. Do we have, did we, I guess we didn't, yes, we didn't put equal sign here, guys. But I did it intentionally because it is length. How about here? Instead of length, it is literally using that index. Amazing, guys, amazing. So forget about length and something. We literally like we have left half and right half, right? So our pointer is going from 0 to these, it covers, these iterates, these indices, right? And this is our, let's say, mid, right? This is our mid. So the last position that it needs to process is literally that. So we don't need to compare. I mean, yes, we don't need to use length basically, right? But even if we do, then our solution should also work, guys, right? I mean, we are not doing something wrong. I mean, P1, like I get it if we use this index. I mean, P1 should smaller or equal to this index because this P1 should process. I mean, let me do this. Nice. P1 should P0, P1, I mean 0, 1, 2, 3, 4. Like this is the last index, right? This is the last index. Amazing. But if we decide to do this using a length, using their length, like it shouldn't be wrong. You may ask, but let's continue. We have while loop. We process left. We compare them left and right. Amazing. If the P1 is smaller and equal, like look at this time, we also used smaller, right? And guys, check this out. So the meaning, guys, oh my gosh, guys, the meaning of this little line, guys, this little line, all right, this, right? You see it, right? You see it. So like we have smaller and this equal, right? The meaning of this line is stability. All right. This means stable. I mean, it affects our. So in code, every line, every character means something, guys. Even this. Oh my gosh, stable left wins ties. All right, so I still don't see what I am missing, right? I mean, like actually the thing I'm missing is temporary and how we use it. Yes. So if I understand the relationship between temp and our original array and how we manipulate our original array, basically, right? Then I will understand. All right. So we compare those values, take the smaller one, and yes, we are all right. So in our code, I use nums. I mean, even in our code, I use nums. No, I didn't use nums. I made the comparison using those characters. Assume that we updated, we manipulated, we changed our original nums. But here, yes, wonderful. We again use our original array, but we are writing onto temp. Why? All right, we assign that value, then mod, all right. Set the value, key plus. Plus, what is this? K, for drain the leftovers, yes, yes, yes. So this is the last, all right. I should understand this part, all right. So we've got everything, oh my gosh. We've got everything right, guys. We've got everything right about this problem, guys. Like, let's say there are 50, 60, 90 lines, right? But these 2 lines or 3 lines, let's say, are the thing that I missed, and it affected very seriously. Let's see what that is. The copy back. Don't forget it. I forgot it. I've forgotten it. So let's see. Like we literally update. Like we are manipulating our nums. All right. So I'm not fully wrong. We are manipulating our original array, but the place where we do is something else that I remember. Here in our code, we don't, like, we are not updating. All right, so this is what I'm missing. So but also, like, it doesn't store. All right. So instead, amazing, guys, we made this mistake. And all right, so instead of creating something from zero, right, actually we are creating something zero. Like we are creating temporary array from zero. Yes. So all right, guys, only thing I really literally, guys, only missing part is these 2 lines, these 3 lines. If I copy, oh my gosh, guys, if I copy these 3 lines and change the name of temporary to result, and also I should change its type to array, basically. But result, we said result, right? Result, but that result should have get method, I suppose. Yes, that's done, guys. 3 lines of code. See you, amigo. Welcome, man. Welcome. Americano. Welcome in, man. Welcome in. Would you like to check tool I built? I will check Coding Barra, but I have limited amount of cognitive energy. I want to use it for lead code, and then when we are free, I will definitely check out. It is my to-do list, basically, right? I will do it. Yes. All right. Allow me to do this, and then
in our free time. We will do it, man. We will do it. So these 3 lines. So, but the thing seems I'm very late. What were you doing, Americano? What were you doing, man? Come on. Like, it's been a while, and I started early today. I started a little bit earlier, and tomorrow a little bit earlier, right? So I have missed these 3 lines. I mean, even we may say that it is 1 line, but the idea was quite important. We are literally building something, right? From ground zero, and where exactly we should manipulate our original array. Actually, I mean, we've seen that this is the place where we should update, but why? How it affects? Why not above this while loop, for example? Yes, why not? I mean, what would happen? What would happen if we do this? If we update our original array before doing that? I mean, it would affect us. I mean, let me answer that. Since we don't have, I mean, we cannot do that because we don't have the temporary array basically completed. So we need to first complete our temporary array. I went to the hospital since I was, oh my gosh. Take care, man. Take care. Be well. Like you said, you were a little bit under the weather a few days ago. I thought you feel better now. Get well soon, man. Get well soon. I thought you are fine, but because it's been some time, right? I remember you said you were sick a few days ago, I suppose, right? 2 days, 3 days ago. Be well soon, man. Be well soon. Health is quite important. Like, if I was sick, I wouldn't open this stream, man. No way. I would be sleeping on my bed right now. Health and sleep, and also lunch, and clear mind, having friends, having a family, right? Good friends, achieving, learning. Like, I need all of these. I have slightly weak constitution. By constitution, do you mean condition? What do you mean? What do you mean? Constitution is like a building, right? On like a US Constitution, man. What do you mean? Also, Wi-Fi is very fast, but Twitch is loading so slowly for some reason. I see. But even on my tablet, it doesn't load fast too. I mean, fast either. Yeah. So we can skip it, guys, and let's save our progress. So thank you, Sergeant. Now, could you please check our findings, our thought process in our notes in all languages project folder? Could you please create those notes? Maybe so, because it has a lot of meaning. Oh, I see. Let's see. Um, Physical health and makeup. Oh, the word describes the physical makeup, health, or structure of living being or substance. If someone is described as having a strong constitution, it means they have robust physical build and rarely get sick. Oh, nice. But you said weak constitution. Probably I'll call them later. Like, thank you, man. I learned a word today. I didn't know its meaning, this meaning, basically, the second meaning. Very nice, very nice. So yeah, so it is updating our nodes. And the thing I was talking about, guys, the overflow is like this currently. I mean, you can calculate the middle point by summing the start position and like start location, start index, and end index, sum them up, divide by 2. But the thing is, guys, if your start point, right, you see it, right? If your start point is quite high, right, like these numbers, after after summing them up, you would get something crazy and boom, right? Whoa, very bad. But instead, we use this formulation. All right, it's updates. We have this, and for merge sort, all right, we can assign add this as a question image, and let me add this like add an echo and make it like amazing because I have done a mistake, right? Actually, not a mistake. I have missed a point where we update. I mean, yes, our original array, and this is important. And this is importante. Gracias, man. Por favor, man. Arigato gozaimasu, guys. Save it. Okay. New term unlocked. All right. Bello, see, bello. All right. Wonderful, wonderful, wonderful. And let's add even some colors to it. And I will, so merge sort. So we covered 6 questions today, guys, which is amazing. Oh my gosh, another thing that I hate most, prefix sum, guys. I hate this. I hate prefix. I hate suffix. All right. I hate prefix sum even more because I keep forgetting it. Like I have even seen a question, like a dynamic programming question, where it formulates the question using prefix sum. Like we need to get familiar with this, guys. All right, this is important, but I keep avoiding it. So oh my gosh. So all right, we will do it. I'm a big fan of Atatürk. Oh, nice. Yeah, he's one founder of Turkish Republic. So modern Turkish Republic. Um, we have said so we should save our pro and we should add another feature. He is well known around the world. Yeah. Notes with audio and video. So please switch to correct branch. All right. And add this feature. Currently, when we open, actually, like in the images section of a marker, all right, we are showing the color, right? We assign color to those images, right? Which is amazing. But when we open those images in their model, we don't have any frame to show which tags that corresponding image has. So could you please add that feature as well, and make sure you are in correct branch. We should merge main to, you know, our feature branch, and then, you know, add that feature, right? What was our approach, by the way? Let's see. Let's go. So we should review this prefix thing, guys. Prefix sum, like even the which problem, cadence algorithm, like cadence algorithm, product sum and I mean no, max sum array and product sum also related to like kind of related to that, like ending at index I, right? So it is like, it is also resembles to that one. I mean, for example, the case where this shines, the prefix sum is range sum query. So imagine you have a program where it needs to answer queries. Which query? Like in that query, it gives you start and an index, and it wants you to calculate the summation in those between those indices, and like it makes this request like a million of billion of times, right? In that case, instead of recalculating those, I mean, summation basically in each query, you create your prefix sum, right? And you prefix sum array once, right? And you make that query use that prefix sum, which is quite faster because instead of summing all the characters, right, you just look at two indices, and you are literally making a one operation. You are subtracting those prefix values, and then you get your result, which is amazing. All right, let me also hunt. Let's see what we have. Yes, go hunt it. Come on, you can do it. Come on, man. Yes, hunt dolphin. Let's see if Americana will be. Oh my gosh, I guess I'm gonna run, dolphin, run. Come on. Oh my gosh. Yeah, so thank you for the color magenta, Americano. And yeah, so this is the case where we need it. All right. Coding Bara is a creature on our seabed. Like, you should use your channel points and add a new fish, man. Why am I saving? No, like you are a creature on that lives on the seabed. It's not a fish, basically. That's why. Let's go. Question. Sakadi doesn't want to its cousin, yeah. Like it has some, like I mean, it must have something to do with their size. I should update this code, Americano. I made them rigid body, right? So when they get closer, their rigid body prevents, I mean, change the direction, change the movement of your fish basically, and it tries to attack, but because of its rigid body, it bounces back. It tries again and it bounces again. So I will fix this situation so that you can have my dolphin, my lovely dolphin. What is Cicade? Cicade is all right. Americano answer that. The question perfect sum answer is, can we pay one-time setup cost? Yes. But I keep forgetting the core idea. Instead of storing the original numbers, store running totals. This is the important thing. The sum, the name of my orca. The sum from index 0 up to each position, Yeah, we know that, but the formulation, guys, this formulation, I hate this formulation. Oh, actually, I am kind of now more familiar with this formulation. Why? Because we have solved this like a product except self question. Um, so um, so here in that prefix quiz, yes, actually it was prefix 2. Yes, while calculating prefix, we were doing something. I mean, we were filling on the fly. We were filling prefix I using using like a previous, I mean, sub problems answer plus the current number. Current number. Oh my gosh, your starfish is hunting. I didn't know starfish can hunt. What is gonna, what is it gonna hunt? Prefix nums I. So this is the way how we structure, how we populate, how we structure our prefix array. Let's say we have 5, 2, 6, 3, right? And prefix array will be like first, yes, first item, first item, first item, and our for loop will start from index 1, 5, and then 7, and then 13, and then 16. So what they mean is yes, this is literally 5, this is 5, 2, this is 5, 2, 3, Happy New Year. And this will mean all of the, I mean, not 2, man, not, why did I type 2? I I used, it is hunting mod. I will add something for your starfish as well, coding para. Yeah, so that it will try, you know, hunting some other seabed creatures. All right. Actually, it can hunt the other seabed creatures. We have other types, but currently we may not have them. In our database, we have different seabed creatures. Is it hunting mode? Yeah. Yeah, but be inside the peaceful mode because other hunters, I mean, other carnivores, not carnivores, yeah, carnivores can eat you. What is this 3, man? What am I writing? So this is, oh my gosh, is Americana gonna be able to eat my dolphin? Yeah, yeah, I see the problem. I see the problem. Yeah, I literally see the problem. It is about rigid body. As it gets closer, it bounces back because of the rigid body effect. I should change it. So you're not gonna be able to eat my dolphin anyway, Americano. My dolphin is lucky because of the back, because of the bug we have. 13 and 16. All right, so this means like we literally, like we assign this first value to our prefix 0, right? We literally, we start filling it, we start by filling it nums 0, right? And then inside the for loop we are filling how we are, right, using I, right, we are filling using previous answer, like this is literally looking like a recursion, right? Like a subproblem. This is subproblem plus the current character, plus the current character. So let's say we are building this one, right? Let's me take this and let me show you why it looks like let me show you the part where I see it as like a sub problem. All right, so like these are prefix 0, right? We have built it. All right, so here, while like here, right, 5 7 5 7, so we are doing that formulation, right? Let me also copy that part. So so we have, like, we know prefix 0, right? Prefix 0, and the current character is 7. So we add them and we assigned this prefix I. So prefix 1. So prefix 1 now is holding 5 7, right? And for 13, again we are going to apply the same formula, and formula says use the previous subproblem, use prefix 1, right, and add the current number. So this is previous subproblem, meaning previous subproblem, like prefix I minus 1. This is previous subproblem, and at the current number, which is amazing. All right, so what were we doing? Yeah, so about the prefix prefix sum. This is prefix sum. Yeah. It's just picking it. It's waiting for something to approach it first. It's just picking it. Yeah. Yes, guys, it's been 6 hours that we were. I mean, I'm grateful. Thank God, I'm grateful. Let's so it's about the question, guys. The question asks, like, find those, like, actually the question is literally asking the summation of these prefix sums, right? No. Yes. No. It is asking the summation of numbers between those indices. To calculate it, we're gonna use prefix sum. Let's see how we are gonna do that, man. But before that, let me lurk some of our friends that is streaming, who is streaming. Let me lurk down. We have friends who is, building games and who is drawing 3D. Like, there are many great people doing great jobs, and we should be one of them, guys. And we are actually we can see ourselves as one of them, guys, right? We are building, we are learning, we are sharing, we are making mistakes, we are learning from our mistakes. So the question is, guys, like, we have an array, we have lots of many bunch of numbers, and we have a query that says, give me the summation between these, right? Dragon, so I'm really not joking. You've been studying since yesterday. I went to sleep and have just woken up for failure. Yeah, like I want to understand these topics, Dragon. I really want to learn these algorithms so that we can build many good stuff, so that we will create some value on Twitch, and I can share my knowledge with my friends online. Thank you for your. I will take it as a compliment. So thank you, man. Thank you. I appreciate it. Did you add your fish in our tank? Did you add your fish in our tank, Dragon? Run fish command right now. Run fish your fish command and add your fish. All right. Um. So our query asks. No, I didn't. You can run fish command. All right. And here it go. Yellow tank. You are yellow tank. Yeah. What a lovely creature. Yeah, it is lovely. And Americano is now hunting. Oh my gosh. He's literally every time trying to hunt my lovely creature. Very sad, man. But he cannot manage to do that because of the bag we have in our game. And so we have a query, right? That query is literally asking the summation of these numbers. So how could you calculate those summation using prefix? Um, Prefix sum. So uh, how how would you do that? I mean, I don't know how would I do that. I mean, like we have prefix, yeah. So all right. So we can use, for example, let's say this is index 1, right? Let's call it even 10, right? 10, 11, 12, and 13, right? To calculate the summation of these numbers, right? Of these numbers. Um, so let's say like this is prefix, like let's say this is not prefix, but prefix at this index, we can make use of, you can use it. Prefix 13. Prefix 13, guys, it means, it literally means all the numbers. I mean, yes, summation of all the numbers. Let me even use another color. Let's use this one. So prefix 13 is literally, meaning this. So prefix 13, right? And we should, find the summation of, nums um, nums 11 plus nums 12 plus nums 13. And the thing we have, like, we know like prefix 13. Prefix 13, guys, is, let me tell you that, let me show you that, nums 13. Oh my gosh. Nums 12 plus nums 11. We will continue. Nums 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. This is what prefix 13 is. Summation of all the numbers, right? But our goal is to find like a summation of nums 11, 12, and 13. And now we're gonna use prefix. Let me pick another color. Now we're gonna use prefix 10, right? Once for all. So prefix 10. So what is prefix 10? It is, guys. Oh my gosh, what happened to my voice? It is, guys. It is, guys. This part, literally, all right, this part. Why? Because it is. I mean, if we write it down, right, like a nums 10 means nums 10. Let me also mark this as marker as what? Prefix sum. All right. So nums 10. Oh my gosh, nums 9. nums 8, 7, 6, 5, 4, 3, 2, 1, and 0, right? So this is exactly the part where we already have inside the prefix 13.
5, 4, 3, 2, 1.
How to yeah. Um so this is literally the same part we have in our prefix 13, right? We have that part. So what are we gonna do with that? Guys, this is the fascinating, this is the most enjoyable part, guys. What are we gonna do with that? Guys, we're gonna demolish. We're gonna erase, right? I mean, we're gonna erase this part, right? Because they are same, right? This is the most enjoyable thing in math, mathematics, all right? They consume each other, right? So what we are left with is what we are looking, I mean, what we are wanting, what we want basically, right? Nums 11, 12, and 13. So the formulation we should do, now we should generalize it. So let's summarize what we have done. To find the summation of 11 and 12 and 13, what we have done, we have like we subtracted prefix sum action, right? Let's call it prefix 13, right, minus prefix 10, right? As we have done this, we are smiling. Why? Because we got this, guys. We got what we want, which is amazing. So this is the number. So we need to generalize it. So how can we define this, guys? How can we define what we want? We can define what we want with like this, like if the query is asking, bring me boy, bring me the values between these inclusive, right? If the query is like this, like we can call it like a and b, right? We should generalize, we should create a formula, right? So when someone asks us to find the summation of numbers between these indices, what we have done is what we have yes, what we yes we come on, guys, it's top of my tongue. We basic, come on, man, what am I trying to do when someone asks these numbers, right? We use prefix some is all right. So prefix, we subtracted prefix 13, meaning this, right? B. We subtracted b, yes, minus, guys, this is the thing I keep forgetting. Look at this now. Prefix b minus prefix b minus 1. Like this little character, this little number makes it is the reason why I keep forgetting, all right? So when someone asks you the summation of numbers inclusive, right, between these and and guys, this is inclusive, all right? So yeah, so if this is also important, I mean, because they can give you like a b exclusive, right? So This is also important. So these numbers are inclusive. So when someone asks you these, summation of these numbers, these indices, right? Your formulation is this. No, not B, A. E, A, to the game. Prefix A, right? Yes, prefix A minus 1. So this is the formulation for calculating the summation of these. Amazing. Now what? Now what? Let's see. Now what? It uses K. Yes, forget about that part. Yeah, we know this. I mean, we know this formula. All right, all right. We already. I mean, let's solve a question. All right, forget about that and let's solve a prefix sum question. Like, let's see what we have. We literally have prefix sum question. Interesting. No, it's the topic, man. Product of array. Oh my gosh, we're gonna suffer, guys. We're gonna suffer. Let's see. All right, all right. Let's have a lunch break, guy. Oh my guys, what time it is? It is almost getting 4. I thought it is 12 or something. Oh my gosh. Anyway. So I'm gonna have my lunch, hopefully, right? And we will continue, guys, suffering. We will continue suffering. No. Let's talk positive, guys. Let's talk positive. Talking positive is quite important. We're gonna enjoy applying what we have derived, right? What we have derived here, and we're gonna apply this knowledge on this creation. So it is literally our playground. Amazing, man, amazing. We are so happy. We are so happy, guys, right? All right, see you, Amico, see you. Let's have 40 minutes break, guys. Like, it's been I don't know how. It's been 2 hours. Yeah, we can have 40 minutes lunch break. Enjoy our aquarium. See you after the break, guys. Take care. Loving you. Break. Let's say 40 minutes.
Enjoy the aquarium.
Hello guys. Um, we will continue, guys. We have great amount of energy, great amount of focus and dedication and motivation and everything we need. Um, and we will like switch gears, right? And um, like since those questions are the questions that I have solved earlier, now like let's create review notes, all right, fast because we don't have time basically, all right. This is why, and we should switch gears and all right. While it is building, let me also fix the issue we have in our aquarium. So I need you to fix this issue in our aquarium. So imagine there is a big fish, right? And imagine it catches, it tries to hunt another big fish. So, but they can't. I mean, it can't because I guess because of our rigid body and because of the way we um, the way we try to hunt, basically, we should improve it, all right? Because it bounces back. It gets quite closer. It gets quite closer, but it cannot hunt, basically, all right? Currently, I am live on Twitch, all right? And you know what they do. So fix this issue. By the way, do I need to start Unity MCP for you, or you don't need it? What do you say? First, we will answer that because based on that, I will close it or it will, be there. Let's see. Now we were reviewing our notes from here, and sort prefix sum, and when I click, yes, now we see the color. All right, so this was about prefix sum and right side view. All right, we have some notes. Let's see, right side view, lead code 3. We're gonna memorize, guys. Memorize. Actually, like, we cannot memorize the questions that we haven't solved, but we can memorize the questions that we have solved. All right, so for example, I have solved this question before, so let's paste it. Let's mark it as this one. And no, you don't need. In fact, please close the Unity. All right. All right, now I closed Unity because I thought to compile you need Unity and Unity MCP basically, but I guess you don't need, right? By the way, when do you need to have Unity? So all right, I guess it will. All right, Yeah, so for this question, right side view, like basically we should go right, and as we go right child, actually it is not always about going to right child, right? Because imagine we have a tree, all right? Imagine we have a tree. So actually not like this one. Yeah, for example, like this one. So here, as we go, we can add, but how about that? Like we don't go right here. We don't go to right here. So it should understand level by level traversal actually. Like it is kinda BFS-ish to me. But how do we do level by level? And also, like we may have different kind of trees, all right? We may have different kind of trees, all right? So what I mean by that, for example, it can be like okay, left, right, and then like this one. So we should understand, for example, the first tree, I mean the first node basically, right? How can we do that? Let's mark it right side view. How can we do that? I mean, maybe we can store, but since if we do DFS, it goes deep basically, all right? Like it starts from here, so and then by the time it comes back, it doesn't go discover the right, so you cannot use DFS. But I feel like there was a thing for let me check this, guys. I guess this one. There was that thing. I remember like I have done something like maybe I can turn this a little bit off. All right. Calling the function calling the function like first func right and then func left. Would it help us? I mean, let's say we have this tree, right? So if your goal is first completing the right child, right? Yeah, maybe this would solve. Yes, this is what I'm talking about. Like we can go to here, right? And then, for example, if we don't have right child, this is not an issue because we can try, and if we cannot go, we can go left. Even that left will have more weight, basically, right? More weight in terms of right side. I mean, it has priority. This is what I mean. Like, yes, so let me take a screenshot, and also we can maybe move this to here and paste it, right? Is this the solution? This is about, yes, this is about BFS. Let's see it. Let's also have its Java solution. There is a 3-question right side view. Give me its Java solution. Let's see its Python solution. What was BFS actually? For BFS, we were using Q, right? We were using Q, and we were adding an element and subtracting from that Q. We had a for loop. Yeah. We had the for loop. We were adding the first, like we were initializing that Q, right? And the for loop, we were, polling each item, and each time we poll, we also add its children to the back of Q, right? Let's see. All right, this is the first approach I mentioned, not a BFS solution, but the thing I realized, it has depth thing. I mean, why do we need to have a second argument about depth? That's a brilliant idea. So it made me remember that we need some state definition. All right, state definition. But I thought this would solve, this would solve our problem completely. All right. Let me even put this here. Let me take a screenshot. All right. All right. So how can we add this to echo? Right, first, that's the whole trick. Actually, without comments, man. Cancel. Give me without comments. Give me, oh my gosh. Give me without comments. Thank you. Paste it. Add to echo. And yes. Our state. In our state, we have something more. Actually, to understand why we need this, actually, this is for understanding if, this is for basically, I cannot see, but coming up with this at first sight is something. So this is for, let's say we have many nodes, all right? So, and let's remove that part, for example, right? For the nodes that are in the same level, right? for the nodes that are in the same level, then among them we should pick the rightmost. But we don't store them, right? Basically, we don't store, for example, level 1's nodes. We don't store level 2 nodes and select the rightmost of them, all right? Actually, this could be a way too. All right. Oh my gosh, look at this. If the result size is depth, so for each level, basically, right? You are adding that node. We are also adding the root. Oh, root is also root is at root is at level 0. I skipped that part, right? And that's why we add. But the thing is, each time we call, for example, we call right? So after, in its stack frame, the first thing we do is adding it. So in the subsequent, like in the other calls, for example, imagine you are, let's say, level 5 or level 6, right? And imagine you have lots of nodes, all right? So for example, this one is called, right? And it will return, and right also will return. We are calling func right, func left. I'm trying to understand. Like, we may have different nodes at the same level, right? And among those, we should distinguish one of them. And at each level, we basically use a key, right? That key is the size. So for each level, for example, here we have at first we have 0 number of nodes. So at level 0, when the size is 0, size is 0, depth is 0, we add that node, all right? And then we call we call depth +1. So yes, so in the next level, depth is 1. Depth is 2 now here. So in that level, we call it again. In that level, we start from here, right? We check if the level is 1 and if we have 1 level of item, yes, so we add. And we go again. And in that level, depth is 2, and we look if we have 2 number of elements. Yes, we do. So like this is working for this part, but how about these parts? How would you, how should we prove them to adding items, adding themselves? Because for example, here we go right again. For example, here we go right again. So going right isn't the answer. Going right and being first at that level, yes, going right and being first. So 2 reasons, 2 conditions. going right and being first in that level. All right. So this part is also quite important then. There are two different conditions for right side view. One is I mean not condition but func right, all right, and the second one is being first in that level. So the way we simulate, not actually, I don't like the term simulate, because we are far away from simulating. All right, forget about simulating. We are not doing things like we do in real life. All right. The way we use, I mean, the way we understand which level we are in, all right, is, first of all, let's start with this. All right, when we make a call, when we go by, I mean, one level below, deeper, all the nodes that in that level will share same depth, right? So this is how they share, right? And in that depth, being first means if you are level at 2, I mean you are at level 2, and if there is 2 elements in your array, meaning you will be the first in your level to be at. So if you are first in your level, then we are at. So because if you are not the first, then you will have more elements, all right, result size. So more elements than the depth. More elements than the depth. So this is very nice. This is very nice. And also I figured that maybe on top of these blur effect, maybe even in the front of car, we can add like a text, maybe like a questions, and maybe even audios. That would be very amazing. While adding an echo, instead of depending on these rectangles on the right side, it would be great if we add. All right, so let's try adding that feature. Yes, I guess you made a commit as well. So another feature. So while adding an echo, right? Like this requires some database change as well. So while adding a echo node, I also want to be able to add a text and even multiple texts, all right, and also audios. For example, when I reviewing my notes, like when I review my notes, I want to see some text, like maybe it can be hint, it can be question, and I want to have some audio files, all right, that I recorded myself. Why? Because when I review a question, like I don't want to depend on the only rectangles that I draw on the image, all right. I may have some, I may add some other questions, hints, some ideas, all right. Can you add this feature as well? Let's see. All right. How about our game? Shipped and verified. The byte check in hunt control now measure a capsule surface gap between hunter and prey. All right. All right. Um, let's try hunting and let's see what. Oh, I ate it right away. I'm a hunter now. Look at me. Oh my gosh. I guess our Americano, I guess you should try our new hunting strategy. Oh my gosh, this is too easy. Everyone will be more hungry now. A bigger one, Econis, side notes, multiple takes, and self-recorded audios. And also make sure that we use same audio style, because in our normal audio recordings, I can add tags like an important question, right? And similar question. And also I can even add captures to those marks basically. So we should share same style basically so that our app is coherent and cohesive, right? All right. Hold on. All right, we are back. And also it would be great if we see the review notes inside the mark, right? Like a browse but filtered. It would be better. So let's add some prey. It is now too easy, man. I hunt right away. It is too easy. I wonder how Americano will hunt. Let's see. Now it is now about the BFS logic. All right, let's see BFS logic as well. Now, can you please give me BFS solution of this? And also, like, we should find a way to make it, let's say, for multiple, for the same question, we may have multiple solutions, but we don't need to have a standalone. Maybe we may need to, but there should be some indicator that you already studied that question, but this is your extra basically. Yes. Let's review. So for BFS, we have a queue. We add that one. So this quite resembles to, like, for example, in prefix array 2, we have we start our for loop from 1, not 0, because we fill our prefix array zeros with a value, so we don't start our for loop right away. I mean from 0. So we poll, all right, and all right, we pull in a number, we pull an element, and we offer its left child and right child at the back. And also, like, there should be a way, I mean, for this application I'm talking about, there should be a way to have like a connected, like a group, all right? Because for example, I wanna, for example, blur here and blur this part as well. I mean, they are same basically, but after offer, this is how we initialize a queue. It's basically a linked list, and also we have priority queue, and priority queue was priority queue, but this is queue, but implementation of it is a linked list. Interesting. After offer, what do we do for that nodes children? And about checking size, and also these two should also be connected to each other. I mean, but we are doing it explicitly. All right. Q. How do we define? Yes. How do we understand if we are adding a item for the first time? This is how we do. When we add at that level, the size should be that. For example, at level 0, size should be 0 before adding, and at level 1, size should be 1. At level 2, so basically we are finding different elements, right? Different variables, and we come up with an idea, like a relationship, all right? Because it is like we basically use the level information to know how many elements we should have for that node to be first. Oh my gosh, like this is smart. This is smart. For this part, let's save it. All right. All right. Coin change. Let's find that problem as well. Coin change, was it DP or greedy? Let's read. All right. Now it makes much more sense. So our big numbers, big coins are, I mean, we should tend to pick the bigger numbers, right? This is why it is greedy. Because if we use smaller numbers, return the Phoebus. So as you see Phoebus, then you may start thinking in greedy basic, all right? Let's say sign is as question image. But it is recursive. Interesting. Do we need to do this recursively? Optimize bottom up. Hold on. Isn't it greedy? Oh, it is. Oh, alright. This is DP. I thought we are solving Lemonade change, man. For coin change problem, we are trying basically every option, right? And let's try drawing this decision tree. I mean, we are trying, for example, each coin, right? And we can pick each coin many times, right? And we should have, like, as a state, we should have like an amount, so that when it hits 0, we will say that, oh, we have found our result, and we can return true, maybe, right? And actually, where are we gonna hold to the number of coins that we have used? So for example, this is coin 1, coin 3, and coin 5, right? So now we have a function, right? We have a function, and we need a for loop to make these requests, basically, right? For loop, we are iterating, right, from 0. When I see this, I immediately understand that in each stack frame we will try everything, right? Yeah. So we will try, for example, how do we show using a coin? All right, how do we do that? We are doing it by, subtracting the amount minus nums or coins. All right, or coins I. All right, so this is how we represent using a coin, and this is the sub problem, basically. So this is sub problem. So what do we want from it to return? It would be great if it returns the minimum number of coins, right? After using that, if let's say if it, like, it should return an answer, right? If it returns minimum number of coins that it can find, and maybe this can also return the minimum number of coins, and this one also can return, right? So we should find minimum of them, right? How can we do that? We can maybe create a minimum, right? And we should update this minimum if if we find, I mean, minimum coin, if we find something smaller than that, all right, so minimum coin, we should set it to integer max value. Nice. All right, like we imagined, these returns, I mean, each of our recursive call returns an answer basically, because each one of them is basically like we can define each of these as a new problem basically. All right, like the reason why like this is DP is because it includes reoccurring basically sub problems, and they return, and we take minimum of them and return the minimum of them. All right, so here the important thing is we set this. All right, so before making these calls, we update our integer max, integer max value, right? We update it. You are doing streaming for almost 8 hours. You didn't tired? Yeah, a little bit. Yes, I feel a little bit tired. You can hunt now, Antonio Morales. I updated our hunting AI, so it is much easier to hunt down. And if you like to hunt, you can do it. Before calling, before making these basically, right? We said, because if we didn't do this, we wouldn't be able to calculate correct minimum amount, because like we wouldn't be able to do this min operation. All right. This is also important because I remember I have spent some time understanding the reason. Understanding where I should put this. All right. All right. So this is the sub problem actually, right? This is the sub problem, and we also need +1. You can run hunt command again twice. Antonio Morales, run hunt command twice. I change it, so if you run it again, you'll be able to hunt. Your turtle got quite, oh nice. Now our hunting mechanism is much more aggressive, and for hunters it is more, it is easier to hunt down. All right, so oh yeah. Like this is the definition of our sub problem, right? How many coins would it cost, a minimum number of coins that necessary for getting this? But from this perspective, right? That's nice. Yeah, thank you. From root perspective, we are using a coin to reach, to get that sub problem, right? To create that sub problem basically. This is why. So let me, yeah. Oh, it is still running. All right. So now for coin change problem, I need you to create this node, this code. All right. So our function is func, and inside of it we assign a variable like a minimum number of coin, right? And we set it to integer max value, and we have a for loop, and it starts from 0, right? And we inside this for loop we make a call again, and as a state, like our recursive function should have a state, right? So in a state it uses amount basically, right? So to call our child, amount minus coins I will represent our sub problem, all right? And we assign its return value to x, all right? And below of that we are using mathmin method, and it is updating our minimum value, basically minimum coin value, all right? If if it finds something small, I mean if x is smaller than minimum coin, then it will update basically. I have 4k channel points right now. Keep saving to get whale. All right. And also I will change the AI for big fish basically, right? I will make it even better, and maybe I can make big fish even bigger. I have little amount of water. So yeah, so and also I realized that to use +1, the meaning of using +1, right? I realized that to create I mean to create a subproblem basically, right? We are using a coin, all right? So that's why this is 1 plus func inside parentheses amount minus coins I, right? Like I really like the idea of state definition, right? Or subproblem definition. So this is literally one of our subproblem, and we will use its return value to decide our parents' answer basically. But to locate it, the position it, this +1 is kind of important, because sometimes it is outside of function, like this one, or sometimes it is inside the function, right? Actually the state definition uses only the amount, right? Because this is literally what our recursive function takes. But also we are combining this with outside variables like a +1, right? We have this situation in knapsack problem as well, right? Yeah. I have idea for aquarium. That's awesome. Now whale become more bigger. Yeah. So I had a for aquarium. What is that, Antonio Morales? What's that? Let's see. And our AI cooked this value. We were here. We were reviewing our notes, and we were in coin change. Nice. And what did we add actually, right? Being able to, all right, so another feature, let's add this feature as well, right? Thank you. Now another feature, currently in our duration marks, right, in written note type, we have images section, and there I want to have a button like a paste button, right? And when I click, I will see the review notes that I have created, like a browse, right? For example, in like inside a written node, below of main nodes, we have echo session, and there we have tabs, and in browse I can see all of the review nodes that we have created inside this written node, right? I want this kind of similar idea in duration marks itself, all right? Because duration mark can have multiple images, right? And I don't know which one of them is basically review node. So like I want a toggle button, and I also want to see the number of review nodes that we have, like a badge, all right, on this toggle button. Yeah, and when I browse, this won't affect the study, right? I'm just reading. You do something like scuba divers can dive in sea, and also you can add ships. Oh, yeah, ships would be a great idea. Fish can fly and hunt human. Like I love the ship idea. We can add some fish, so maybe there can be. I mean, one of our viewers can be like a fisherman, like a ship, and they can try hunt a fish. Fish can hunt each other, and also people outside, like above the sea level, they can hunt. You can add also abandoned ships. Oh, that's a very nice idea. That's a very nice idea, Anthony Morales. I loved. Let me save that idea. I really loved that idea. I was looking for something to add in the background, and abandoned ship is the most, beautiful beautiful idea to do game. All right, thank you. That is wonderful idea. That's a wonderful idea. I love it. Abandoned ships, very nice, very nice. All right, so we will add this. It will add this button as well. And let's see if we have this. All right, so this is top-down memoized, and this is unoptimized. All right. Yeah, minimum coin. I don't know why we have this, but for this one we make a choice basically. Actually I don't like doing the +1 here. All right, so let me tell AI so that it fixes. So in unoptimized recursion solution, we are adding this +1 inside the mathmin function, but I don't like that idea. I really enjoy you seeing 1 plus func. All right, I love seeing this. Seeing them together basically. So do this addition, right? Oh, but I guess there is a reason why we didn't do that, right? Because in the comments you say child was solvable. So what do you mean by that? Why do we need that if statement? I guess it is because of the way how the question is structured, right? So let's say if our like if it is guaranteed that number of elements we will have is like, oh, yes, it is not about the number of elements but the total, like a summation. Because let's say our coins can be like a 50, 100, a billion maybe, right? And we may have a question where like we may have a target, right? We have an amount, and to find that amount maybe we should have, let's say, 20 level of depth, right? Maybe 30, 50. And if the values is quite high, we could sum and we could end up with having like a great number. So this is why we need, but imagine it is guaranteed to have good numbers, all right? So I guess we can remove that part. And also um yeah, like I didn't think about this another if, like this coin overshoots, skip the choice. I didn't think of that one as well. What is the meaning of that? And give the question, I mean, give the solution like the way I described. Like, of course, I can think of this case where the summation gets quite large, but I don't want to give any cognitive energy for those mm, relatively trivial cases, all right? I want to focus on um, more important parts. I remember a formula that was used in Excel. It's like that if command, well, if true, well. I remember this I learned in MS SQL. Okay, MS, not SQL, Excel. Formula that was used in Excel is like that. If command, yeah, value of true, yeah. So we are doing something like that. Antonio Morales. Um, yeah. It is similar. It is quite similar. The overshoot skips. The overflow is not from big coins or deep recursion. Remember, func returns a count of coins, not a. Alright. If the coins are the answer. Alright. The count can never exceed amount itself. Smallest coin is at least one. So for lead cost, limit x is always a modest number. Integer max value is not a computed result. It's the code we choose to mean this amount is in. Oh, it's the only giant number in the entire system, and we planted it ourselves. Depth doesn't matter. Coin sizes don't matter. A single +1 on the centimeter wraps it to a negative number. Then matmin, which trusts numbers blindly, lets the impossible path win. Oh, so the reason why we are having this line basically, it is because we are eliminating a case where it can return into minimum value, basically, like integer min value. I still don't understand, but this is not something trivial. This is about something else. I thought this is about the total amount, and we are not calculating the total. I mean, we are calculating total amount, but number of elements. We are not summing those coins basically. We have amount and we are decreasing that amount, and if that amount hits 0, then then we return 0. Exact change reached, 0 more coins needed. Interesting. Quite interesting. I would say we would return 1. This coin overshoots, skip the choice. How can we overshoot? And overshooting means like, overshoot means like we need coins to reach to the amount. But if your coin is bigger than amount, then you cannot use that coin basically, all right, in your solution. So this is why we are making that choice, and like I don't understand why we have this. Like if it is not equal to integer max value. I learned some codes watching your stream. Wonderful, wonderful. Antonio Morales. Like loops, nested loop. Yes, yes, yes. I'm happy to hear that. Happy to hear that, Antonio Morales. Um, I don't understand why we are checking this one. X. What does X mean? X means minimum number of. Actually, this has something to do with this one. We are setting it to integer max value. All right. And we are making choices. All right. So let's try drawing. We are making these choices, right? And before making those choices, we create integer min value, right? Integer max value. We set min to max value. Nice. And they return some value, right? And we add 1 to them, and we need to find the minimum of them, right? Yes. Before even adding 1 to so it means this function can return this one. How? If for example I mean when exactly this function returns integer max value. Let's read it. You cannot subtract blindly. Can go negative. 1 plus max value overflows. All right. So for me to care about this overflow, first I should understand why. I mean, why and how this function can return this. Because we are updating, we are setting. So I don't see it basically right now. I mean, we set it to max, but we made these calls. So is it possible for example for x to return max? Like how? Trap 1 is you cannot subtract blindly. Why? Can go negative. All right, it can go negative, and if it is negative we can return 0. Guard it with the continue at the top of the loop. At the top of loop. By the way, why don't we do this here, right? But here, yeah, this is also quite important. So for trap 1, we are having this continuum, right? Actually, it is not about coins amount is bigger than the amount. You are talking about amount minus coins can go negative, you say. So if the current coin is bigger than amount, we don't make a recursive call that would have a state where the amount is negative. So we literally limit that. We avoid that happening, right? We avoid it happening. We don't have any stack frame where our amount is negative. Wonderful. But I don't understand the trap 2 Meaning, I mean, let's say we have like imagine a node, all right, and that node will have three children, right? They represent our coin. It represents our coins. So is it really possible for any of them to return integer max value? Like, I don't really see it. Like, in what case they can return this integer max value? Because from my perspective, when we create a state, right? Um, I mean, there is no way it can return max value because we are setting it. We are, yeah, we are setting it. So could you please clarify on that? I really don't see. Let's see. We should understand this, and let's see the current situation. We said after clicking 9, yes, we have one echoes, nice. Yes, this is it. All right. But also we should be able to see, I mean, we should able to see it as if we clicked on the browse. I mean, it's details basically. What did I, how did I take a note, basically, right? Um, Thank you, amazing. But the thing is, when I clicked, I want to see as if I clicked on it in a browse section, in our echo section, right? Because here in browse section, when I clicked it, we open in a browse mode, seeing all of the total reviews they studied, all of our notes, right? I want to see this part basically for that image. And also both in browse tab and also in this, for example, in this browse, say they are same basically, but I also want to see the front of the cart, all right, meaning as if I clicked to review basically, all right. Maybe you can add a button or something, all right, because right now in a browse we show the card, it's question basic, it is a related question, it's history, activity, amazing. But I want to see, for example, which hints I have there, which parts that I blurred, for example. Let's have this feature as well. Let's see what we have here. Excellent question, and we are setting it. Observation is exactly the right place to look because the answer is hiding in the initialization becomes the return value whenever nothing beats it. I need to see this basically. You are picturing a node with 3 children, each child returning some answer that flows into math. Yes, that flows into math mean. In that picture, sure, min coins always get overwritten and max value never escapes, but that picture has a hidden assumption. I love this hidden assumption. Hidden assumption. That the children exists. Yeah. Look at what trap 1 does again. It delays children. Every coin that overshoots gets continued. No call is made. No X exists. Yeah. So if we skip every one of them, I mean, if we don't make any call, right? Like this one, right? This one, right? This one. But still we have set this to mat mix. Mat mix. Mat max. All right. So like, all right, we need to cover that case as well. All right. What happens to a node where trap 1 deletes all 3 children? It doesn't delete. It just don't create them. Let me also ask this one. So my beautiful amazing cloud, you said that what happens when it delays, but basically we don't delete, right? We don't delete our children. What we do is basically we don't create them, right? Yeah, for example, if coin's value exceeds our amount, for example, the parent does not create that children. So if a node does not create any children, then I guess we should, handle this cage, meaning it can return max value, I suppose, right? But could you please clarify on that? Is using delayed term here, I mean, is it wrong? I mean, it kind of looks off to me because we don't delay it. We just don't create that subtree or that state, that subproblem. All right, it is building. Very nice. Amazing. You cut me in sloppy word. Your correction is more precise than my sentence. Let me both concede and sharpen it. Oh my gosh, concede and sharpen. I'm curious to ask what's the concept or reason behind your avatar is. It's kinesin. It's a motor what? Motor protein, and it carries a cargo. Like it is a element in our cells, and it carries cargo. Let me show you. Let me show you it. Kinesin motor protein. It is actually this, right? And I really love how it moves, and it really amazes me how it moves and does its job tirelessly, right? It's quite fun to watch it because the move, like the way it moves, is quite nice. Look at it. This is kinesin, basically motor protein, and this is how it moves basically in our cells. Very long, like it goes very long way. It carries this for a very long path, and let's look good in moving. Yeah. You cut me sloppy, yes. Delays. Yeah. Your voice to text play the trick, but your objection applies. A recursive call tree isn't a data structure sitting in memory waiting to be trimmed. Yes, a child is nothing more than a recursive call that actually happens. The continue doesn't remove a child, it means that the call is never made. Why did I say delays? Because there are two trees in this conversation, and the word belongs to the other one. Oh my gosh, I thought Claude will, confess. Claude will admit its mistake, but the conceptual decision tree, the imaginary complete tree of every possible choice, every node has one child per coin always by definition. This tree exists only in our heads as the map of the problem. Actual call tree, the trace of calls that really execute. Children exist here only if the parent creates them. Yeah, so like even in both of them, we don't delay it. When we reason about the algorithm, we usually stand in picture 1, describe the coast guard as cutting branches off the full tree. That's the standard term, pruning. And Trapman prunes those children is how a textbook would say it. When we reason about what the machine does, we stand in picture 2, where your wording is the honest one. The subtree is simply never constructed. Same fact, one touch. What is that? One vantage point. Pruned from the imagined tree, never created in the real one. My delays was picture 1 language dropped into picture 2 sentence, which is exactly why it smelled off to you. Good no. Thank you, Glad. Thank you for complimenting my nose. We were here, we were there, and here in 9. In echoes, when I click, amazing, man, amazing. So when I click here, we have, all right, so card front, nice, close, amazing. All right, very nice, wonderful. All right, so, and yes, your conclusion carries over untouched, just reverted into your framing. And note, actually guys, let me add Antonio Morales' idea into our game while we are learning, while we are come on, where are you, man? All right, while we are connect to MCP server, and yes, so now you can connect to our Blender MCP, right? And our goal is now adding an abandoned ship in the background of our camera, our aquarium, basically. All right, I'm imagining like a ship from 14 centuries, 15 centuries, like a wood. All right, you can use Blender, design something. I'm imagining like a ship, like a part of it, like a small part of it inside the sea, right? But most of it is outside, and we can add some shining plants there as well, so that when we run color command, we will see. All right, yeah, build and design such a thing on Blender and implement it into our game. It looks cool, excited to see. Yes, I really wonder how it will look. Yeah, let's go. Just rewarded into frame. A node that creates 0 children has nothing to override its initializer. So it returns max width. All right, so this is the reason. So give me the code without comments. All right, now we will study greedy gas citation, but the thing is, I also want to, yeah, I also want to, do we have something, no, we actually even, interesting. And also I want to see this problem from our contest, the last div 3. Pascal, I guess this one, right? Yes, it's calendar and drawings, and actually even this one, right? This was a good question. Like I couldn't solve it, solve this question yesterday. Let's see its answer, and also give me an answer for that. Our goal is here now grouping basically, but yesterday when I was solving this, I couldn't manage, right? We need to group the sharp sign, sharp characters, right? And as we see star character, we should reset it basically. But I couldn't do it, so give me the code in Java. Like I will also solve questions from code forces. Like I really loved the div 3 and first 3 questions. They are very good questions. Where is our node? All right. For gas citation, like the idea is for leaving from each station, we should have net positive amount of gas, right? And also another important thing was, let's say you start from station A and you go station A, B, C, D, right? Which is amazing. And let's say you failed at station D. What happens then? Like you conclude that basically even you basically started, if you started back from gym, welcome man, welcome back. How did it go? How did it go? Welcome in coding. It was fun. Nice, perfecto, mucho perfecto, amico. So basically, if we left from, let's say, station B, then it wouldn't give us any better result. All right. So we basically eliminate those options very fast so that we shrink our search space, right? This was the idea from this game, this not game, this gas station problem basically. Let me have the solution. Interesting, look at that. Oh, all right, so we're decreasing. All right, post decrement. We read best and current. If the current is this one, we increase and we update. If it is not this, we basically reset. And answer is best plus 1 divided by 2. Oh, like this also includes a detail why we are summing by 1. How is it going? It's going great. We added some new features in our note application, and we are reviewing our questions. Um, like tomorrow, guys, I will try reviewing all of them, all right? Because we cannot spend, let's say, mm, more than 15 minutes for each problem, all right? Or maybe 10. I will create an desktop application, all right? And we will see a counter basically, because like these are the questions that I have solved earlier, right? Um, but reviewing them is quite important, all right? But for example, today for prefix, we have for merge sort, we have spent good amount of time, but actually those time is required, man. Without spending those time, I mean, how do you plan to understand basically, right? um, but we should basically increase the weight of memorization, all right? um, because like I want all of these questions fresh in my mind. So like since I already solved them, we don't need to basically spend that amount of time. Actually, we didn't spend that huge amount of time basically. um like look at these notes, guys. They look amazing, right? They look amazing. Yeah. All right, all right. Our goal is basically reviewing all of these 49 questions tomorrow, all right, guys? We should do this. Oh my gosh. For example, LRU cache. Like, I remember I spent good amount of time solving and understanding these actually. Um, all right, all right. We will look at, I mean, we will think about it for 1-2 minutes and then we will skip. Like, like, for this question, I'm quite familiar with it, and like we don't need to spend too much time. um yeah, but for some of them we need to spend a bit of time. Heap sort, all right, so we will complete merge sort, quick sort, and heap sort. Amazing, amazing. um Knapsack, all right. I have studied knapsack, so it shouldn't be too hard for us to review. Like tomorrow, guys, we will review basically, all right, all of these questions. And can't good notes. Oh my gosh. Edit distance 3, set mark to zeros, happy number, bubble sort. Yes, all right. If we do this too, heap sort, quick sort, merge sort, and bubble sort, we will cover them all. Currently we are here, guest station. But we should be able to add review notes as well. If we spend 15 minutes each, 15, oh my gosh, if we spend 15 minutes each, it would mean 12 hours, 13 hours. Let's say 15 times 49, right? Yes, 49 divided by like a 12 hours, right? 12 hours straight, and we don't like we shouldn't exceed 12 minutes. I mean, not 12 minutes, 15 minutes, because like there are some questions that may take like a 30 minutes, right? Look at this amount, man. But tomorrow we should do it. 12 hours is a lot. Yes, I totally agree with you. but we should review them. We should definitely, like, I mean, all of them should be fresh. all of them, all of them, all of them should be fresh. Antonio Morales. So amazing, man, amazing. And let me create another skill for maybe tomorrow. Tomorrow, should we use it? Yeah, let's create another skill. Like, I created a skill for dedicating 45 minutes. Yeah, you should do it. Nice, nice, nice. Tomorrow we will start earlier, even earlier. So it's gonna be 9 hours now, and 9 hours. Yeah. Tomorrow I will start. Earlier. So yesterday we have created lead code marathon, stuff like that, right? Now I want another version of it, and in that version we should make it like a 15 minutes. In 15 minutes, like, most of the time I will use this skill for reviewing all questions that I have already studied, right? But we should be fast, and I will explain you my thoughts, and you will generate answers and give me hints based on the time duration, based on the elapsed time. We should be very fast because tomorrow I want to review 50 lead code questions, and I want all of them to be fresh, all right, in my mind. And I mean, I cannot spend more than 50, I mean, maybe 20 minutes. Like, if I don't understand it, maybe we can make it up to 30 minutes. But since I want to complete all of them, we should do it under 15 minutes. But you should have open door, basically, right, to make it like a 30 minutes. Like, if you sense that, like, I don't understand, or I'm missing a quite important point, then you can basically direct us, basically, right? So, but the weight of 15 minutes should higher than 30 minutes, all right? Cool. So when did you start? When tomorrow? Most probably quite early. Not quite early, but around 8 a.m. 8 a.m. is quite early. Like, around 8 a.m. Around 8 a.m. Yeah. Till what? Till 8 p.m. Yes. 8 p.m., 9 p.m., 10 p.m. But at most 10 p.m. I want to keep under 10 p.m. basically. Yeah. Because if I exceed that, I mean, if I go beyond that hour, then the next day I feel quite tired, demoralized maybe. If we can finish our job basically before 9 p.m., 10 p.m., it is good. Yeah. And also I will create a desktop application, like, so that on the screen we will see counter, all right? Yeah. The game is coming, Antonio Morales. Let's see how it will look. Don't expect, like, keep your expectations low. We may need to iterate, but let's see how, I mean, what Cloud built for us. All right. All right. Let's see a review question. All right. Yeah. So I also said that I want to be able to add like a text and maybe voice notes, right? To and while creating a review note, I want to be able to basically uh, I want to be able to add. All right. Um, Good night, Antonio Morales. Sleep well. Um, our our ship is here. It looks amazing. I mean, you don't see it, right? Let me show you. Our ship is there. It looks good, but its color, we should change its color. So it really looks nice. Maybe I can share some image of, yeah, that looks good, right? We should we we can like its color should change, and maybe I can share some images with AI and it can build what we want basically. But this is cool as well. Yeah, this looks quite nice. Let's make it red. Yeah, we should update colors basically, right? I will find some images from web and we will make it look better. But it is fine. It's fine. So good sleep, Antonio Morales. See you tomorrow. All right. Sleep well and good sleeps. We wish you good sleeps. Thank you, thank you, thank you. I also said that I want to be able to add like bye bye. Chia amiga. Hi, welcome Saran. Welcome in, man. Welcome in. Welcome in. We have we have a ship inside our aquarium. We ending? No, like we don't. We don't, but I am kind of getting tired, so I'm getting tired, so we are close. But if you like us to continue, we can continue for next 5 hours, man. Just tell it. Just tell it, man. How do you stream for 9 hours straight, bro? Respect. Thank you, man. I appreciate it. Like it is thanks to you, man. Like you really motivate me. For example, yesterday I was sleeping actually. Like I took a nap right before the Code Forces contest basically, and you guys woke me up so that I could join. I could participate that contest. It was amazing, and also Solaris, Lazy Skimmer, and Americano, like they really motivated me. All of you guys. So and also I really want to learn these topics basically. All right. I'm really pushing my limits basically. But having you here, knowing you are there, watching and learning, maybe like if you learn something here, I will feel like a much better, right? And we discuss about topics we enjoy. We have our aquarium. We have our aquarium, and it's quite enjoyable. Let me tell you that it's quite enjoyable. And like the game, oh my gosh, game stopped working, guys. Oh, all right, it's getting built. All right, now we are back. Um, yeah, like I hope you become successful and oh my gosh, man, I appreciate it. I appreciate it, Saron. Thank you, man. Thank you. I really appreciate it, man. Thank you. Thank you, man. I really appreciate it. Um, can you run follow me, Saron? I mean, or my fish, so that we can see your fish and how it is doing. Is it well? How does it do? Let me also. All right, this is also building, reshipping. All right. We added a fish into our game. I mean, not ship. I don't know my sea orchestras. Like you can run follow me command, right? Like this one. Let's see. All right. Mine is discuss like this fish, and it's swimming very nicely, very slowly. Oh my gosh, we don't see it. It is nice. You built an amazing ship, which is awesome, but the color is kinda wrong because it looks. I mean, it should look like it should have like a brown colors, right? Currently, it is like a black, right? We don't have any black ship, right? It should be brown. Let's update the color of ship we have, right, in our aquarium. Let's make it brown. Um, all right, let's yeah, like we also should able to add, but actually this is review. So how about when I try to add an echo? Wonderful. I am now able to add a note and voice record, which is awesome, guys. Um, all right, all right, all right. We have this feature, so which is amazing. Gas station, remove. All right, let's look at this one, man. What should we do? All right. Lead code sprint, how it differs? We have lead code sprint and lead code review. 15 minutes is a cap, not a target. A fresh problem should close in 5-8 minutes. Clean recall means we wrap early, no padding. This matters because, yeah. 3-minute recall gate versus, yeah. Use take that pattern plus approach from memory in one breath. So if it doesn't come by minute 3, I reveal it immediately. This is review. So redraiving for 10 minutes is waste. All right. We don't have any time for wasting, guys. We should do this very fast. You talk, I type. In the reconstruct phase, you dictate the core logic, the loop, the invariant. All right. What the data structure stores, and I generate the code. Your keystrokes are never the bottleneck. I flag core mistakes only. Nice. The open door to 30-minute works exactly as you asked. I extend only when I detect a genuine conceptual gap, misremembered invariant, confusing the problem with the sibling. Yes. Yo, Kinesin, guess what? What happened? What happened? Tell us. Tell us, man. What happened? Redeem. All right. Let's like I have little amount of water. I'm thirsty. Thank you, man. Thank you. I appreciate you, man. Thank you. Like I literally finished. Like it was not full. Like it was not full, but it was this, right. It was this level, and it takes around 2.5 liters of water. Yeah. Holy water intake. Our ship is looking even worse. Thank you, Claude. Like I mean, you built like you made it brown. I drink about 4 liters. Like you are doing good, man. You are doing good. Um, I will drink more before sleeping. I mean, during next break. Like you made it brown, but it doesn't look very like a very gameish. like it doesn't look like it doesn't look like it's coming from a movie. So how can, like, maybe you should switch the texture you use, the material you use, because it looks like a paper, brown paper. Like, we should use a good material. So can you make an online search and find maybe open source ships or stuff like that, or maybe even better, use which materials we need to use, like the lighting, the materials, like we should care about them, man. And maybe you should increase the detail level of the of on top of these surface level of this ship, right? Like, it is brown but it doesn't look good. It's because I play football or soccer, as you call it. Oh, all right, all right. But it's look. I mean, it is even better. You play. It is better that you play football. We, like, in Turkey we call football in Turkish football. In America, in Europe they call it soccer, right? And in America, in United States, they call football, but they call football in different thing, I suppose, right? American football, right? Yeah, like, you are doing good, man. You are doing good. I mean, playing sports is quite good, you know. You you basically use your body to create something. A state level player at 7. Oh my gosh, man, you are doing perfecto, muco perfecto, man, muco perfecto. State level. That's very nice, man. That's very nice. I wish I spent more time, like maybe like a walking, running, right? Maybe swimming. I like quite swimming, but I didn't find a good, swimming pool. But I can go to the sea, right? Like, sea is like a 15 minutes away. Yeah, I should swim more. But I'm quite happy that you play football, soccer. It's quite good. It's quite good. Because it even helps your brain function better, right? Like, your body becomes stronger, your blood flow becomes. Teşekkürler kardeşim. Eyvallah. Thank you, Siron. Did I do it right? Or no, this is good. This is good. This is correct. Teşekkürler. Teşekkürler kardeşim. Yeah, it means thank you, bro. You did correct. You did correctly, man. Build for batch days. Give me the list of 50 upfront. Probably because its own clock. The stamp shows. Very nice. Very nice. We can give these questions upfront so that it can build a plan for us. Nice, guys. Should we do it? Should we do it? I suppose yes. I suppose yes. Thank you, but I mean, also we should also focus on the implementation details as well, right? Like, I should first remember or create the logical part, and also like implement, like, because while implementing, there are some other stuff that emerge, all right? Because while solving it like a pseudocode or focusing on the logic, it is quite important. Like, this is the first step, but when it comes to implementation, like, for example, there was a question where we were using like compute if absent in Java, right? Like group sum. Yes, no, not group sum. Group anagram. Like, I didn't know the that method. Actually, without knowing it, again, I should be able to solve it. But that method, it is really helping. And also, like, there's a priority queue, right? There is priority queue in Java, right? For example, we were creating a mini heap, right? And also, like, we were yeah, I guess we were creating min heap, but we were using maximum numbers, and we were keeping the length of our heap with top k frequent element. Yes, I'm talking about top k frequent element problem. So we were keeping the number of elements in our heap k times, right? So by the end of it, we will have only the topmost k. So we are building a min heap or vice versa. I don't remember exactly, but the thing I'm trying to make, the point I'm trying to get is you should carefully handle this, like a both logic and the maybe implementation details. All right. I don't know why there's a delay between the video and the voice. Oh, I restarted my browser multiple times, or I'm going mad. What site are you using for Claude? Like, um, one of our friend also mentioned about this audio. I will check this out. I will check this out. What site are you using for Claude? What do you mean by site? What do you mean by site? What site are you using for Claude? I mean, I don't use any site, but I didn't catch the question. All right. Taking. All right. All right. We'll be here. We'll be here. We will be here. Um. All right. Thank you. Thank you for the learn. Let's see. Let's see. Tomorrow is gonna be legendary, guys. Oh, okay. I guess our ship is looking better now, right, guys? I guess it is now looking better. From memory, one breath, pattern and approach. I mean, the thing I remember is like we were using like a priority queue basically, and our goal is to find top k frequent elements. So maybe if we get rid of all the elements, I mean, I don't know how can we, you know, have a heap. I mean, the thing I remember basically using a heap and getting the top k basically, and we were using, like we were creating this heap based on like we have a hash map as well, and we were creating this heap, like populating this heap by based on their frequencies. All right. This is what I remember for now. Let's see. Let's give a shot. You know how it will work. Skeleton is right. Hashmap counts frequencies. Heap ordered by frequency. Target come out. One probing question before you reconstruct. Min heap or max heap, and how many elements does it hold at its biggest? This is where the star of this problem lives. And how many elements does it hold at its? Yes. How many elements does it hold at its? Like what one probing question? One probe. I also like the term probing. One probing. One probing question. Like if we use min hip, as we add, still we keep the minimum. We add another one, still at top we have, you know, minimum. So if we create minimum hip, and then if we have a design, right, to get rid of the others, and we can do this by popping. No, but if we pop, we lose. Oh, we lose minimum. Oh, yes, yes. I guess I remember now. Our goal is to build minimum hip. Our goal is to, you know, build minimum hip, and when our size, I mean, I remember something like removing when the size of hip gets, to K, right? To K. But I cannot visualize it basically. If we have a minimum hip, each time we add an item, we still hold the minimum of them, alright? And if we remove, if we pull an element, alright. If we pull an element, we pull the minimum. We don't pull the maximum inside the min hip. We pull the minimum. So each time our hip gets the size of K, if we pull, we are getting rid of bad stuff, basic, the unwanted stuff, right? We are getting rid of those stuff. So that remaining parts will tend to be bigger, right? I guess, guys, tomorrow is gonna be legendary. We will talk, we will type. Let's see how it functions right now, how our skill functions, because we need to limit the amount of time we spend for each question, guys. There are lots of questions, guys. Believe me, there are lots of questions. And like I remember I spent 4 hours for a single question. That's it. You rebuild the inversion. What does inversion mean? Like, and also I don't like. What does inversion mean? Every pole ejects, eject. All right. The current weakest, and so the K strongest survive. Oh my gosh, I really love this term. One precision fix: you evict when the size exceeds. Yeah, we can do that. Exceeds, not K. The heap leaves at K. Briefly swells to. Oh my god. What does this word mean? Swells. Marker. Let me add a marker. Swell. And also eject and inversion. Like I can create basically like a what? Like a daemon, right? Command, so that we can save the words. Logic stands. Now the move lines. These are yours to write. I'll take the boilerplate. Assume this is already done. Can't merge. Actually, I don't know this merge, man. You give me in Java the priority queue declaration. It holds the numbers, but orders by what? What exactly? Write the comparator. The loop body, the offer line, and the eviction line. All right. We should review this. All right, this is amazing. So for priority queue declaration, it is like, oh, maybe for this part I should type it again, because describing it by words is not a good way. So for this part, what do we have? I mean, priority queue, right? And maybe integer, right? And queue and new priority queue. And this is like that. Oh no, actually we also have how we want to structure our priority queue. How do we want it? How do we want it exact? Oh my gosh, guys! I was showing the I was showing the aquarium, but now we are back. Priority queue, and we also should define based on what we are I mean constructing. So A and B, like A and B, they mean there will be count. All right, count get A, for example, right? And minus count dot get B. So why are we doing that? Because this is like this A and B represents the nodes that we have in our queue, and we are gonna basically sort them, right? Structure them based on their frequency. I mean, if the frequency of A is smaller than B, then A will be first. So we are creating an ascending order. We are creating so, and also let me ask this. Because this is the second time our viewer said this. So now I am still live on Twitch, and like today we had some complaints. Our friends on Twitch said that there is a delay between voice and video. So without breaking anything, could you please analyze the situation? Because tomorrow I don't want this happen again, basically. How can we analyze? How can we make sure? I mean, what's wrong? Well, what's being wrong? Let's see. I'm checking for friends and what they are doing. On Twitch. All right. We may have an issue with the synchronization basically, and we should fix it. What you doing, man? Welcome, man. Welcome. Welcome, man. Doing some lead code. Let's see our task, my task. You made it amazing, but also make sure that our ship doesn't basically smash our board. We have a board. Comparator is correct. Min heap keyed on frequency, clocks forcing to hint level up. So here's the loop shape. Fill the two blanks. Oh my gosh. This is very nice. For loop. I'm still sleeping. Sleep is good coding, Bara. Like after the gym, I mean, you can rest a little bit, right? One breath, what goes in the blanks? So basically here, I see count.k set. So we are processing the keys, right? And we are offering those keys into our queue. Yeah. And we have an if statement. What are we doing with that? I mean, we have an if statement, but which condition should we have and which operation should we do with this queue? If the size is exceeding k, we should poll. So the second blank is poll and the first blank is checking the size of our queue basically, and I guess this is a size method, right? In the frame reef taskboard slot is sitting inside. Yeah, all right, so it is fixing that. All right, so tomorrow guys we will review every one of them. All right, we're gonna review every question we have here because I really love this skill. Review log. "16 minutes rusty. The inversion you recovered yourself and the computer was clean, but the eviction loop needed a scaffold at 30. All right, it gets a review. Oh my gosh. 3 days later, the eviction line will be the first question. Oh my gosh. One observation from this test run for tomorrow: the clock set idle. Between me asking from yeah, in a real problem, I'd escalate faster there. Actually, in that time, I was looking at some other stuff. All right, I wasn't paying attention to you basically, right? Um, because tomorrow I will dedicate my time to you specifically. And maybe we can review one question. Let's do this. We can try with another question as well. Now I will practice this question as well. I mean, we will have our review notes in our, not application, right? And also, this is amazing, but could you please move that ship a little bit further? Like, we don't need to see it right away, right? Like, it's like a background entity, all right? It will bring us some, not authenticity, but there was a word like not authenticator, right? Authenticity, I suppose. What does that word? One no pace worry, then the mechanism is fine. So from memory, one breath, pattern and approach. I mean, the thing I remember from this problem, I guess it is linked list, right? So we should remove a node from n. So like the thing I remember is like we start not from the first node, right? But let's say if the k is, let's say, 5, we start from the 5th node, and when that node reaches to the end, our like a casual like an index pointer will be the position where the question asks. So, and I guess our goal is also like a removing that node. So since we are at this node, while we are moving, maybe we should also keep the previous node as well. And while we are there, we should be able to make the previous node next node to our next node. This is what I remember. So I like this skill is working amazing, but how about the implementation? You wanted me to do something, but I wasn't paying attention to you. I'm on stream and we are solving lead code problems. Earlier I asked you to clap once on camera so I could measure the audio video sync precisely. You didn't, but it turned out fine. You were talking during the main recording and your mouth movement versus your voice gave me the same measurement. Result, your stream is in sync. The delay your viewer complained about is on their end. Most like the Bluetooth headphones or stuck Twitch player session. Tell them to refresh the player or toggle the quality once. And alright. I guess we don't have any audio issue. Lead code problems. It has added a marker. So So now please make an online search, find designs, but like we have some plants that gets color, like a shining color. I guess you should also use correct materials, correct light choices, all right? Because their default color is looking terrible, right? It's like a greenish. And when they get color, like I want to see some glowing effect. Like maybe you can use Blender or something, but I want to see glowing effect. Um, Maybe you can make an online search and how other people do this, because I've seen some effects, right? Some light effects. We should add those effects. Let's make it. Let's make our game even better, guys. All right. This two-pointer gap approach. Lead pointer starts and ahead. When it hits the end, the trailer is standing trailer at the target. Prev.next kernel unlinks it. One pass, no counting. So now the implementation move. All right, we have implementation part as well. By function, your prev idea works, but there is one input where the previous node doesn't exist. First node. What if the node to remove is the head? I mean, there is one line move that makes that special case vanish entirely. What if the node to remove is head? So for head node, I mean, we for head node, I mean, like if we have, actually we cannot decide and we cannot foresee what we have, right, before moving, before basically processing all the nodes, right? So but you are telling me that if there is a node that doesn't have any previous node, what would we do? Like we would set prev to null. We can assign prev to null, and it can start null basically. And as it goes to the next node, we can then update our prev, right? But I guess yes, like this is not a recursion, so yeah. Let's see. This skill is amazing, man. Based on the elapsed time, it decides where to focus. Revealing the move, 20 seconds cost a rusty node, not minutes. Your prev null plus branch works, but it forces an special case. The move is the dummy sentinel. Create a fake node in front of the head. Oh. And start your trailer there. Now every real node, including the head, has a previous. Oh, I guess we have this mini pattern. I guess we have this mini pattern in a LRU cache, right? I guess there we like for head, like for head and tail, we are adding some virtual or imaginary, or what is the word for that? Imaginary or additional nodes basically, right? The dummy declaration, it points to head, where lead and trail start, and how far you advance. Oh my gosh, this is good. This is good. The walk loop, both move until lead hits the end. The dummy declaration, I mean, for dummy declaration we can initialize basically, right? I know it, like a node, right? Node head. and it points to head, you say. We can assign basically our head to that value, right? Where lead and trail start. Lead and trail start. I mean, as you said, lead starts head dot next. Maybe we can make our lead equal to head dot start, head dot next. Oh, trail will start from head dot next, and lead will start from. We should have a while loop, and we should go, let's say, 5 times, right, forward. Actually, if it is 5, it should be 4, right? Because, like, I mean, if we, yeah, like from head, it should go 5 times forward. Which friends do we have? I am kinda getting tired. Reconstruct. The word is sentinel node. And yes, LRU cache is the same move doubled. Dummy head, dummy tailed. So insert remove never special case the ends. You are drifting on starts. Both pointers start at dummy, not head dot next. You are drifting. Nice. Here is skeleton at rank 4. 3 blanks, and blank is exactly your 5 or 4 question. Like I should type them too, guys. Like tomorrow while we are reviewing, I should also like switch to the code and little type these parts. All right. The dummy node, dummy next is head. Oh, I thought we are assigning, head dot next to dummy. No, it is not like that. All right. We literally have a dummy node. I mean, oh my gosh, it got crashed. We literally have a dummy node, and we are making its next to our head. But what do we earn from it? What do we get from it? How far ahead must lead get? How far ahead? How far? 5 times. Like if k is 5, we should move it 5 times. So trail lands on the node before the target. I mean, if our goal is to, land on. Actually, I forgot our goal basically, but in the for loop, the I should be less than the value we have, like in our from our argument basically. If we have 5, it should be 5, like smaller, less than 5. Walk both until lead is where. Both walk until lead is where. Lead is actually, there are 2 places, right? We should care about them. If it is maybe like a last node, or beyond that? How do we decide on that? And like I feel a bit tired, so I'm drifting. But you are saying that the unlink. What do you mean by unlink? And what was our goal in this question? Basically, I even forgot that. Sorry, I'm a bit tired. Like, I guess the goal was to remove the last element. I mean, last k element, right? Last k node, right? So to our first goal is to locate, to know we are inside the current, I mean, correct node. And our second goal is like removing it. For removing it, we should find the prev. We should know the prev, and we should set its next to the current next, so that we basically remove it. Yeah, but I didn't understand the dummy idea basically, right? Why do we need that? Let's see. And let's see our aquarium, guys. Make it aqua and see the colors. Yes, they are better now. They are better now. And also maybe we can make our board a little bit shiny as well, right? Because these plants are looking amazing. And actually I really want to something glowing and moving at the same time. Can we have a amazing? Now I want another plant type where it moves, right? It moves and also it shines, all right? Can we have a plant like that? All right. Currently some of our plants are moving, but our shining plants, they don't move. Like, can we, maybe we can make them moving. And also the plants that in the background, they are too large. They shouldn't be that tall and that large. Could you please fix them? Locked. Remove end from end. 15 minutes rusty. Guys, like we are rusty on almost everyone. Review on the 18 opens with by the dummy. And the n plus 1 off by 1. 2 review, 2 rusty, 0 gap, which is exactly what this mode is for. Both problems are now warm again, and both got their weak spot named for the recheck. And the skills full loop is tested and working. Gate, move probing, clock escalation. You are tired and tomorrow 50 problem day. I would stop here and come in fresh when you start tomorrow. Just say review mode. Alright. And also, like, I wonder, like, we can start this skill from various topics. So how do you plan to manage where to save, basically? Where to save your review log, basically, right? Um, the skill now pins the log to the one global file. That's what I'm looking. That is what I'm looking for. You can start Litco review from any directory. Home. Yes, yes, yes. And every row settle lands in the same file. Nice. One nuance to be aware of: the clock files were already global, so timing was never affected by the. Sorry. let's see. We have find a way to make Cloud our private tutor, guys, and it's gonna be legendary. From memory, one breath, pattern approach. The thing I remember from group anagrams, it resembles to anagrams, problem, alright? And anagram means same characters with the same amount. So we literally need like a frequency array or hash map, right? And also in this question we need to group the anagrams, right? Group the anagrams. I mean group same anagrams in the same list. So we should have a detection system to understand, right, which word will belong to which group, anagram group. And since we don't know how many groups we need to create, it should be dynamic, I suppose, right? If there is no group with the current identity, and also like we should find a way to distinguish our like words, right? And how can we do that? We can do this by, I get like, since I remember how we do it, we can do this by basically getting the characters of that string basically and sorting them, right? And sorting them, and that thing will be key for us, and our system should be able to detect if there is a group, like there is an existing group for that key or not. And the method we were going to use that for that is compute if absent. And compute if absent is like a get method and get or default method, and it will take a key, right? And if there is let's see, if there is a key, then it will return its value. If there is no value with the given key, it will create, for example, it will create new array list most probably. All right. So this is what I remember, but I am having hard time remembering how compute if absent works actually. It was taking a key, and then also it was taking like a new, like we were literally using a function like compute if absent method, and the how we initialize a priority queue is quite resemble to each other, right? Because both of them takes function as an argument, right? I mean, in a priority queue, yeah, like it was literally taking an argument, and here it also takes a function, which is new, which is initialization, basically. Let's see. Let's see what Cloud will tell us based on the elapsed time. Gate passed, logic fully recalled, sorted string as the group's identity. Yes, this is quite important, guys. Map key, these groups are created on demand. Only the moose shape is missing. Your priority queue connection is right in one sense. Both take a lambda. Yes, lambda, like by a function, I mean lambda. But the lambdas answer different questions. The priority queue's lambda answers who is yeah, smaller, 2 inputs, compute if absence lambda answers if this key has no value, what should I create? What should I create? Or like the definition here is amazing, and this is just perfect. Returning a fresh value. So the shape is map compute if absent the key and key fresh. Yeah. So yeah. So it returns the list existing or just created. Yes, existing or just created. Amazing. So you can chain add right onto it. Write the full line, key is the sorted string, and the word gets added to group. So if we should get, right, we should sort the current string, the current process string, right? And after sorting, maybe we should store it in a character array. And after storing it in a character array, maybe we should turn this character array into a string, right? So that it's a key, right? So that we can use it. And like a map.compute if absent, we should use the key here. And lambda will be like a new array list, like, because this is what I remember basically, creating a new array list and adding add method. And what are we gonna add actually? I think we should add the current process string, right? We should store those strings basically, right? Yeah. Let's hunt, guys. Hunting is too easy now. Yes. Let's follow me. Let's run. Follow me. All the pieces are there and correct. Sort character array back to string the key. Nice. The lambda creates array list. Nice. You add the original word. Yes, not the sorted one. Yes, all right. The sorted version is only the identity. The original is the data. Now the literal syntax. Type say the two lines exactly as Java. The key lines to character array, sort and new string. So basically, like, we are processing each string, we turn them into character array, we sort that character array, I suppose. But how do we sort that character array? I guess using arrays.sort method, right? Yeah, I guess using that method. And what would get now? All right. So after sorting that character array, we should turn it into string back again. How do we turn character array into string? I guess it was. Is it like a new string? No, I don't remember actually. You said new string method, but and also you said one-liner. Map.compute if absent. We should use that key basically. The string that we have created as the first argument. As a second argument, we should pass a function which is new array list. Yeah. And to chain, we should add the original, as you said, original word, right? Which is string coded. We are inside for each for loop, so Let's see. Answering the direct question and leaving you exactly one blank is a constructor. Oh, we can literally use characters to generate a string, right? We can do this. Interesting. I wanna add a marker in our chat, right? We can initialize a new string object using this. You were right the first time and doubted. So we are processing each word. We turn them into character arrays. We used arrays classes static method, which is sort, which is important, guys. And I literally forgot this, right? I mean, basically creating a new string object using characters, like using character array basically. The move one line, and we return a new array list with the values of each key basically. You have already spoken every piece of that blank. Compute if absent. The key, a lambda that makes a chain f o yes. Write it as like map dot compute if absent, right? And as a key, what is our key? Our key is this, and as a value, as a value we basically initialize a new array list, right? Yes. So, and if there is already an array list, we add what do we add? We add the current word, which is our word, right? How about that, Cloud Code? What are you gonna say? Let's see. I really love this new skill of ours, guys. I really love this. So it really works amazing. It has a time escalation rule. One token away. The second argument cannot. Interesting. That's a ready-made value. Compute if absent once a function it can call only if the key is missing. Yeah, that's the compute in the name. Oh, all right. It computes lazily. Never wastes a list when the group already exists. You wrote exactly this shape an hour ago. Oh, I I really forgot that part actually. Interesting. I thought it expects us to literally like calling the. Oh, actually, the thing I have written is literally calling the initialization, right? Initializing. So, but instead we need this little thing. I don't know, but yeah, I totally understand now, because in the first version we I literally called the function, right? I didn't pass the function. I literally called that function. So yeah. So, and what is this called? I mean, I guess this is why it is called lambda, right? Most probably. Let's see. Let's hunt a new fish, right? Come on, little little fish hunt. And also after hunting on the screen, I want to have like a notification, right? So that it is more visible. All right. Today was amazing, guys. I appreciate you, your support, your companion. It was great. I am really grateful. Tomorrow we will continue studying these lead codes. I have built an amazing skill, right? And with the help of that, we won't spend, we won't waste any time, all right? Because we need to cover all of these, right? We have lots of questions, and these are the questions that I have solved earlier, and I want them to be fresh in my memory. So, but I keep like I tend to like use, I mean, too much time actually, because I remember I spent 4 hours for a single question. That's not the correct way. In 4 hours, I could solve maybe 5, 6 questions, right? Um, so yeah, it is rusty. The logic was your cleanest recall of 3. The shaky part was exactly the move, lambda. And the frame pasta recipe, not the cake, is in the ledger for the recheck on the 18th. Worth noticing across all 3 test runs, your logic recall was solid every time, yes. What wobbled was always the implementation move. Uh, so we literally missed the implementation details, guys. So the logic part remains fresh in our memory, but the implementation details, all right. Heap eviction, sentinel node, the lambda. That confirms the instinct you had this morning when you asked me to add implementation details as a recall target. It's precisely where your reviews earn their value. The skills tested and ready. Tomorrow, review mode, your list of 50 from any directory. Get some rest. Thank you, Sergeant Cloud. It was amazing working with you. Yeah, we appreciate your companion. We studied amazing. So see you tomorrow. We're gonna basically crash all of the lead code problems, and see you later. See you tomorrow. Take care. Say hi to your family. All right. So it's been now 10 hours straight. We've been working, guys. I really appreciate your companion. Today was amazing day, and tomorrow, hopefully, guys, it's gonna be even better. At ease, soldier. It was a great session. The skill got battle tested on 3 problems. The ledger stocked, and your recall is sharper than you give it credit for. The logic was never the problem. Tomorrow we drill the moves until they are reflex. Yes, I want them to be reflex. So see you tomorrow for the 6th sleep well. I'll pass your regards. I will pass your regards along to the server rank. Guys, AI is going somewhere, which is crazy, man. Like, to be able to make this joke, like it really understood my intention, right? Like, look at the emojis. So now, guys, what do you recommend to basically rate? Oh, we have a friend over here. So guys, tomorrow we will start even earlier. So take care. We love you guys. All right. Let's rate this friend of ours. All right. Thank you guys. I appreciate it. Was great. So let me also find my outro. Where is my outro? Actually I have, right? It was 9.